All right, made it full screen. Okay, good. So now today is the slide seminar, and it says the title of the slide seminar is Spindle Cell Lesion. What next? Okay, now a tumor is also a lesion, so I didn't write lesions / tumor. Okay. Let me now go to the next. Why isn't this moving? Yeah. Now everybody knows that you can see over here a spindle cell lesion, and the subject of this slide seminar is what next. But before we go to what next, I don't know why we've got this bad echo. I hope it disappears on its own. The first thing that we have to ask before we go next is what first. Okay, so what first, and what first is to define what is a spindle cell. Okay, so now let me ask one of the young people over here. We first of all need to know what is a spindle, right? And I've shown you some spindles over here. It is something that is used. It's a long, slender pin. It can be of different shapes, and we call it the spindle because there is thread that is twisted around it or wrapped around it, and it is used during spinning. Okay, you see there that you can see some iconic figures. One of them is standing on a charka, and the other one is, of course, who is it? Can you tell me who that is? Diksha?
Winston Churchill.
Winston Churchill. Yes, very good. Why is he being shown over here?
He has a cigar in his mouth.
Yes, he has a cigar in his mouth. I don't know which is why you're getting this bad echo, but
I'll check. Anita.
That's okay. I mean, I'll continue, but we can. But you have different kinds of shapes of the spindles. Okay, there is one that is tapering at one end. You can see that this spindle is tapering at one end. You can have something that's fusiform, and we use this term fusiform. And you see that means both ends taper. And then you have a cigar shape, which is actually like a cylinder with blunted ends at either side. Some cigars do have a slightly pointed end, but most often cigars have a blunt end and a cylindrical kind of shape. So all of these are essentially spindle cells. So now, Diksha, I want you to answer. Can you tell me, now that we know what is a spindle, what is a spindle cell?
Spindle cell is an elongated cell whose nucleus is more than 2/3, length is more than 2/3 of its width.
All right, so that's your definition of a spindle cell. Does everybody agree? What about you, Deepali?
Yes, ma'am.
Deepali?
Yes, ma'am.
Do you agree with that definition of a spindle cell that Diksha just
yes. Yes, ma'am.
You agree? So can you repeat it, Deepali? What is a spindle cell?
Its length is 2/3 of.
What the length of what is 2/3 of the width? Length of the cell? Deepali? Can you hear me? You know what I'm asking? What is the definition of a spindle cell? And Diksha, can you repeat it, please?
Spindle cell is an elongated cell with a moderate eosinophilic cytoplasm or spermatozonophilic to moderate cytoplasm and elongated nuclei whose length is more than 2/3 of its width.
Okay, so now Deepali, you heard Diksha?
Yes, ma'am.
Right, so good. Tell me, what did she say?
Elongated cell whose length is 2/3 of its width.
Elongated cell whose length is 2/3 of its width. Okay, Aditi, is that what you heard Diksha say? Aditi, are you there?
Ma'am, a spindle cell is a cell which is an elongated cell in which the nucleus has the length more than 2/3 of the width and has a moderately eosinophilic cytoplasm.
Oh, so the spindle cell is defined by the color of its cytoplasm. Is that right, Aditi?
No, ma'am, I repeated what Diksha said. You asked.
Did she say moderately eosinophilic cytoplasm? I didn't hear that. I thought she said moderate amount of cytoplasm. But what do you think? Okay, you repeated what she said. But please tell me, what do you think?
No, yeah. Moderate to scant amount of cytoplasm.
Okay, so according to you, the cytoplasm defines a spindle cell. Okay, Aditi, let's ask Elsa.
Madam, I think it's the nucleus that defines a spindle cell.
Oh, so Elsa has said something which is quite revolutionary. She says that it is the nucleus that defines a spindle cell. Will you repeat what you said, Elsa? Elsa, you there?
Yes, ma'am.
So just repeat what you said. So you're not worried about the cytoplasm or the shape of the cell. You're only interested in whether the nucleus has got a spindle shape. Is that right, Elsa?
No, ma'am. Spindle cell is elongated with the nucleus. The size is the length of the nucleus is 2 times the breadth of the nucleus.
Okay, so you believe that a spindle cell is an elongated cell which has a nucleus that is actually spindle, right? That's what you said. Okay, good. Priyamada, do you agree?
Yes, ma'am.
What is it that you agree with?
Elongated cells.
Yes, tell me.
Elongated cells with elongated nuclei more than 2/3 of its width. And the cytoplasm could be moderate to scant. It could be eosinophilic also, or it could be basophilic also.
So essentially, what all of you are saying is that you have a spindle cell is defined, as Elsa said, by its nucleus, provided that nucleus is within an elongated cell. Have I understood all of you right?
Yes.
Yes, because, and that's what is that the definition of a spindle cell. It's an elongated cell with an elongated nucleus within the cytoplasm. Okay, I think that's very important. It has to be within the cytoplasm. The nucleus has tapering ends and is at least twice as long as its width. Okay, now it is a reasonable assumption that if one sees a spindle nucleus, that the cell itself is spindle. And I think that is what Elsa was trying to say, that a spindle cell should be defined not by the fact that it is elongated, but that it has an elongated nucleus. Although one may not always see the cytoplasm. All right, Shashank? You're there, right, Shashank? My goodness, we're really getting a lot of echo. Now, what should we do? Sumit, do you think that I should log out and try and log in?
I think I will mute all the students one by one, and that's only Shashank. Shashank, you're there?
Yes, ma'am. Yes, sir.
Yeah, I think we'll mute all students and see that one by one. Shashank, you continue to reply to Anita.
Okay, ma'am.
Yeah, there's somebody saying something in the chat box. Say, I don't know whether. All right, Shashank,
Yes, ma'am.
tell me what you're seeing in this slide. Just describe it. Do you see spindle cells in this slide?
Yes, ma'am. I can see spindle cells. They are elongated cells. And,
Okay.
yes, ma'am.
All right, you can see spindle cells in the
Are
slide.
in a
Do you
parallel
see any
flat
other kinds of cells in the slide, Shashank?
Yes, ma'am. I can see other type of cell. They made a separate boundary and they are
Uh-huh.
oval to polygonal shape, ma'am.
They are oval to polygonal shape. What is oval to polygonal shape, Shashank?
Ma'am, ma'am, some are oval and some are some.
That's fine. But what is oval? What are you seeing as oval? Then we'll come to the polygonal. What are you seeing as oval? And I assume that you are.
I'm talking about, yes, ma'am. This seems nucleus.
You're talking about the nucleus. Yes.
Yes, ma'am. Yes, ma'am.
Okay. Good. So really, what you are talking about, Shashank,
Yes, ma'am.
is this area, right?
Yes, ma'am. I'm talking about this area.
That area. All right. So now you're saying that the nuclei over there are not spindle. Do I get you right, Shashank?
Yes, ma'am.
Very good. And they are oval or they are round. Isn't that right?
Yes, ma'am.
Excellent. So what was polygonal over here?
Ma'am, some nuclei are different from. Yeah, ma'am. Not typically polygonal, ma'am. They are almost oval.
So then use the word that you want to use. So what
Yes,
is the
ma'am.
word that you want to use?
Ma'am, round to oval.
Round to oval. So what is a polygon? You had a nice lecture on polygonal cells. So why do you call these polygonal?
Yeah, ma'am.
They're not, right? And really, you're not talking about the cells, Shashank. You were talking
Yes, ma'am.
about the nucleus. Am I right?
Yes, ma'am.
All right. So now you tell me, what is this that you are seeing in this otherwise spindle cell lesion? What is this that you are seeing? Yeah, you've drawn. I have outlined it, and I'm doing it again. So that
Yes, ma'am.
nobody has any doubts about what Shashank is talking about. Yes.
Yes, ma'am.
So now what happened? Are these spindle cells, Shashank?
Mm.
The answer is very simple: no, yes or no. Are these spindle cells?
Ma'am, boundaries. You're talking about boundaries.
Now I'm talking about whatever are those cells that are within this red and white region that I have drawn. Are those spindle cells? Shashank, the answer should be simple. No, it's either yes or no. So what do you want to say? We have
Ma'am,
just, you can see the definition of the spindle cell is right there.
Yes, ma'am.
So
No, ma'am.
is
They
it a
are.
spindle cell or not?
No, ma'am.
You don't think it's a spindle cell. All right. Let us ask Aditi. Do you think that these cells that are within the area that I have demarcated, are they spindle cells or not? Come on, Aditi.
No, ma'am.
Aditi, are you there?
Yes, ma'am.
Very good. Come on. Are these spindle cells or not?
No, ma'am.
No, ma'am. Okay, so we're going to take a poll now. Aditi says no, ma'am. Shashank says no, ma'am. Kedar?
No, ma'am.
No, ma'am. Chandana?
No, ma'am.
No, ma'am. Very good. Priyambada?
Yes, ma'am. These are spindle cells.
They are. Okay. Diksha? Diksha? Are you there, Diksha? No. Diksha has muted herself.
No, I muted Diksha and Dipali just to check.
Sorry. I'm so sorry. Diksha?
Okay, Diksha, I muted. Diksha, I'm unmuting you. Yeah.
Are these spindle cells, Diksha?
Ma'am, can be spindle, maybe transfer section.
Okay. Elsa, are they spindle cells?
Yes, ma'am. They can be the cut section.
All right. And Dipali?
Yes, ma'am. These are transversely cut.
So 4 of you have said that these are indeed spindle cells, and the rest of you, including Shashank and Kedar and Chandana and Diksha, sorry, not Diksha, Aditi, have all said that these are not spindle cells. They are spindle cells.
Very
And
nice.
how do we know that they are spindle cells? Because we should be thinking in 3 dimensions. Okay, when you cut a fascicle and you see all these cells that are running around in all parallel to one another and parallel to the direction in which that is running, these are fascicles. And when you cut a fascicle transversely, you can see. So if I want to cut this fascicle transversely, okay, so let's try that experiment. If I cut it like this, what do you think it will look like, Shashank? What will those same cells which are spindly, now what will they look like, Shashank? Are you there, Shashank?
Yes, yes, ma'am.
So what will they look like? I am
Round.
cutting, they will look
Round.
round. Obviously, no, because I'm cutting something that is long
Yes, ma'am.
transversely, so they will look round. So now, please, this is the first thing that we have to learn about spindle cells, okay, that they may look round. That means the nuclei will look round, and their cytoplasmic borders also will look round. And there were several people in the chat box who said the same thing, okay? All right, let's go to the next slide. Now, there are elongated cells, and they might have spindle nuclei, but they are not spindle cells. Now, Shashank, can you tell me why? What is this? What have I shown you on the left-hand side here? What is it? Can you diagnose what those cells are? And they are cells. What are those cells? Shashank?
Yes, ma'am.
The left-hand side.
Yes, ma'am.
What is it?
Ma'am, they are muscles, striated muscles, ma'am.
They're striated muscle. Very good.
Yes,
Do they have spindle nuclei?
Yes, ma'am.
They do. Why are they not spindle cells? And we do not refer to striated muscle, skeletal muscle, as a spindle cell. It's an elongated cell. It's a really long cell, so long that we call it a muscle fiber. Where are the nuclei of these muscle cells, Shashank? Can you see them? They're
Yes,
here,
ma'am.
no?
Yes, ma'am. I can.
So you can see them. You can see the nuclei of the muscle cells. They are there. But they are not within the muscle cell. All muscle cell nuclei, skeletal muscle cell nuclei, are at the periphery. So strictly speaking, we do not refer to these cells, although they are elongated. And they do have spindle nuclei. they are not referred to in common everyday pathology literature as being spindle cells. Okay, there is another muscle cell that will be called a spindle cell. Which one is that, Shashank?
Yes,
This
ma'am.
is a skeletal muscle cell, and we don't refer to it as a spindle cell. So which is the
Yes,
other muscle cell that will be referred to as a spindle cell? All right, Shashank is taking time. Kedar, which is that other muscle
Smooth
cell?
muscle, ma'am.
Smooth muscle cell, yes, because the smooth muscle cell is an elongated cell and it does have a spindle nucleus, and that spindle nucleus is sitting inside the cytoplasm and not at the periphery of that cytoplasm. Okay, and now here you have another elongated cell. You see the long axons, okay, but these are neurons, and we don't refer to neurons as spindle cells. And the nuclei anyway are not spindly; they are round, but they have very long axons that go all the way from sometimes from the base of the skull, depending upon what neuron you are or what nerve you are talking about. It can travel long distances. The axons can travel, and those are not spindle cells. All right, good. So now spindle cells, if we want to understand spindle cells and try to use our understanding to make diagnoses, we have to see in what kind of patterns these spindle cells grow, in what kind of patterns. And so here, these are patterns that many mesenchymal lesions grow, but the ones that grow, and what the spindle cell ones grow in a certain number of different patterns. Okay, fascicle is one, a sheath is another, a herringbone pattern is a third. You have storiform or a cartwheel pattern. You have palisades. You have a hemangiopericytomous pattern. You have a plexiform pattern, and you also have no pattern at all, which we call haphazard. Now, spindle cells, by and large, do not form rosettes. That is another mesenchymal pattern altogether. But spindle cells can also produce, can also lie within a matrix, and that matrix may be mixoid, it may be mixochondroid. Sometimes you get spindle cells in bone and cartilaginous matrices. It's not very common. And the most common matrix in which you see a spindle cell is collagen, or the spindle cells may be so closely packed that you can hardly see any collagen or any other matrix at all. So now we need to know what these different patterns are. Okay, and let's talk about the different patterns. Now we saw the first pattern over here, and we said what it was. Yeah, what pattern is that, Saida? The one on the left?
Ma'am, the first one is fascicular pattern.
Yes, it's a fascicle. And can you define what is a fascicle? Saida?
The cells are arranged in a slender bundle or a pine needle-like structure.
Slender bundles. Here's a bundle. Yeah, you can see this. I had outlined that bundle, right, Saida? Yes? Yes or no? I told you this. We said that bundle was cut at right angles. At right angles, okay. So it's not a slender. Is it a slender bundle? No. So slender has got nothing to do with the definition of a fascicle. So what is the definition of a fascicle? The definition of a fascicle is you see spindle cells, and you can see them all here, all running together as a bundle. Here that bundle has been cut transversely, but otherwise they're all running in a bundle parallel to one another, and each of them is running parallel to the direction in which that bundle is running. So if I have to show it to you, here you are. This is the direction where you see that big black arrow in which that bundle is running. You could say it is running in the opposite direction, it doesn't matter, but the bundle is there, and you can see that all these cells are spindle number one. You cannot get a histological fascicle. Okay? You can get a muscle, any elongated group of cells or fibers can be called a fascicle. A nerve is called a fascicle. A skeletal muscle bundle is called a fascicle, but not because it is composed of spindle cells. Histologically, if you have to define a fascicle, it must be composed of spindle cells, which are placed parallel to one another, and they run in the direction in which that fascicle is running. So they're parallel to one another, and they're parallel to the direction in which that bundle is running. Okay, so that is what is called a fascicle. Okay, now we come to the next pattern that you see over here. Okay, Deepali, what is this pattern that you're seeing here in the next slide?
Storiform
pattern. Storiform? No, I don't think that is storiform. Diksha?
Ma'am, herringbone.
Herringbone. Who said that?
Diksha.
Diksha, yes, it's herringbone. What is this herringbone pattern, Diksha?
Ma'am, it looks like a spine of a fish herring with cells in the fascicles and some in the acute angle.
Right. So Diksha, you can do an annotation, right? Yes, ask for an annotation, and please show everybody where is this herringbone spine. Have you asked for an annotation?
Yes, ma'am.
I've received it. Okay, come on, show me. Use the thickest, any color that you want, but use the thickest, the little dots at the bottom. Press on the thickest dot, and show me where you can see the herringbone. You're right, it is herringbone.
Oh, it's going.
That is not a herringbone. No,
Here,
that's not the herringbone. So let us see where the herringbone is. Okay.
Here.
The herringbone is here. You see it.
Yeah.
What? That is the herringbone. Okay, that's the herring. I mean, they call it you can take any other fish which has what? It's got a spine, and it has got bones that are deflected away from the spine, but not at right angles. They are deflected away in an angular fashion. Now can you see it? Now can you see it, Diksha?
Yes, ma'am.
Yes, where?
Here, lower down.
Very good. That's the spine. Excellent. And yes, and there you are now able to see.
Here.
Yes, now you can see that these are all the different, the ribs of that fish that are being deflected away from this thing. So very good. So this is a herringbone pattern. Okay. Good. Now I think I have a thing here that you can show it. See. So that was the spine of the fish, and these are the deflection of the ribs, which you call, I mean, they're bones, obviously, of the fish. So that is a herringbone pattern. Now, who's going to take the next? Come on, Aditi. What's this? That is seen. So this is, of course, a herringbone pattern. The next one, Aditi, which is on the right. Are you there, Aditi? Or maybe Aditi has disappeared. I don't know. Priyamada, are you there? Very good. Come on.
Ma'am, I think
First of all, is this a spindle cell lesion?
ma'am, I think this is palisading pattern.
You think it's a palisade, so define it. Why do you think it's a, how do you define a palisade?
Ma'am, individual cells are arranged parallel to each other
So why is it not a fascicle?
vertically.
Vertically means what? We just saw a fascicle where the individual cells were running parallel to one another. You're right, I can see them running parallel to one another. So why isn't it a fascicle?
Fascicles.
All right, so you're having difficulty, Priyamata. All right, let's ask Elsa. So, do you agree it's a fascicle?
Palisading pattern.
It's a palisade. Okay, so why is it a palisade? She said something about being parallel. Yes, they are parallel. You can see, right? All
ma'am.
the nuclei are parallel to one another. But why is it then not a fascicle?
And the nuclei are perpendicular to its axis.
Then the nuclei are arranged, sorry?
Perpendicular to the axis.
Exactly. All right. It is, somebody says it's a sheaf, it is not a sheaf. This is a palisade. The nuclei are all parallel to one another, but they run perpendicular to the direction in which that axis, that bundle is running. So you've got a bundle of spindle cells. All the nuclei are parallel to one another, but all of those nuclei are perpendicular. Very good, Elsa, to the direction in which that bundle is running. Okay. So this is the direction in which that bundle is running, and you see that all the nuclei, in other words, the cells, because if you've got an elongated nucleus, you will have an elongated cell, are all parallel to one another, but they are perpendicular to the direction in which that bundle is running. Okay, and therefore this is a palisade. And apart from spindle cells, Elsa, do you see a palisade in any other cell? Can other cells form a palisade? Yeah, Elsa? No? Okay, let's ask Chandana. Chandana, do you know of any other cells that can form a palisade? Saif Ali says that it is a basal cell carcinoma, forms a palisade. Everybody's talking about basal cell carcinoma. Do you agree, Elsa?
Yes, ma'am. Basal cell carcinoma does
Where is the
palisading
palisade?
of cells.
Where?
It's peripheral palisading.
Peripheral palisading. Is there anything that is not peripheral and can form a palisade? So what do you need for a palisade, Elsa? You need what? Are the basal cells, are they spindle cells, Elsa? Basal palisading. Are they spindle cells?
No, ma'am.
Yes or no?
No, ma'am.
No. Very good. So they're not spindle cells. And yet we see palisading. Why? So the palisade is not something that you only see in spindle cells. Okay. What do you require? What is the minimum requirement for a palisade? Somebody's talking about glioblastoma. Somebody's talking about, that is palisaded necrosis. Yes. So what do you require? What's the minimum requirement that you need for a palisade? It's certainly not a spindle cell. So
Elongated nuclei.
nucleus, you need the nucleus to be elongated.
And base, a base, a ground.
You just need an elongated cell. So a columnar cell. Yes, a basal cell. A basal cell that has got an elongated body. Yes, all columnar cells can show you a palisade, right? Because they are all parallel to one another and they are perpendicular to the basement membrane. Yes or no? So to form a palisade, you don't require a spindle cell. But many spindle cells do show you palisading. So will somebody be able to explain that to me now, Kedar? What did you understand about a palisade?
Yes, ma'am. Basically, what I understand is the word palisade refers to a wooden wall. I mean,
It's not a wooden wall. It's not a wall. It is a fence.
A fence of a vertically lined, say, wooden spokes parallel to one another.
You have slats. So you have wooden slats, right? Yeah.
Yes, ma'am.
Very good. Yes.
So
So-
cells bearing resemblance to this structure can be called palisading, this type of arrangement.
Right. So what is the minimum thing that you require? I can't be running to the book every time to check whether it looks like a fence made up of
Elongated
slats.
cells parallel to one another.
So you require. So what does a palisade? There are many kinds of fences, but a palisaded fence has got cells that are elongated, with or without elongated nuclei. It doesn't matter what the nucleus is for a palisade. But if I'm talking about spindle cells that are forming a palisade, then yes, the nuclei have to be elongated because that is what defines a spindle cell. Do you understand that now, Kedar? Does everybody understand it? If there is a problem anywhere, then please let me know. It's important. Okay. Okay. Very good. There are some more spindle cell patterns. Now that you're on there, Kedar, can you tell me what is the pattern on the left? What is
It
the
appears to
pattern?
be a cartwheel pattern, ma'am.
Oh, I'm talking about this. Is this cartwheel? This one? You know what I'm talking about now, Kedar?
Yes, ma'am.
What am I talking about? I'm talking
The
about,
leftmost image, ma'am.
yes, the leftmost area. This one. I'm talking about this thing. Okay, so what is the pattern? No, Kedar is having difficulty. Shashank, what is this pattern that you see in this left-hand side thing? There are people in the chat box answering. All right, Chandana. Yeah, Chandana. No? Okay. Diksha.
Ma'am, hemangiopericytoma like.
Hemangiopericytomatous pattern. Yes. And this is not correct. Diksha, is it the spindle cell that's forming this pattern or what is forming the pattern?
Ma'am, vessels are branching in the staghorn like.
Exactly. So many spindle cell lesions have a hemangiopericytomatous pattern. This is a spindle cell lesion, except that it has been cut so that you can't see the spindle cells except in some particular areas because the spindle cells are in a haphazard pattern, but they have a consistent relationship to the vasculature. Okay. So this is a pattern of the vasculature. Very good. So now you can see this vasculature, and if you look at it, it is a staghorn vasculature. Can you see this? That's a stag. A stag is a male deer. Okay, and among some deer, only the males have got horns. So this is a staghorn, and you see how beautifully this vasculature, whether it is that or it is some of the others, really represents the way that the stag or the male deer's horn looks like. So this is what is called a staghorn pattern. Aditi, we come to the next pattern now.
Ma'am, it looks like a story form or a
Story
cartoon.
form pattern. Why do we call it story form? You're right. What is story form? Why is it called story form?
Ma'am, it looks like a cartwheel kind of.
Yes, it looks like a cartwheel. It looks like the story form comes from this rush mat. You know, when they used to weave these mats which had a circular, sort of semicircular areas. Yes, but the easiest way to, to talk about this is to. So that is the stag-on thing. The next one is this. You see this? What we used to use as kids. I don't know if you still use that. It's like a little wind whirl.
Paper fats that we used to take.
So you see that?
And run.
And you can see how well it matches what you are seeing. There is a condensed point of collagen. Usually it is collagen, or where all the cells come together, and then they whirl away from this particular central point. Okay. Now who's there next? Elsa, you want to tell me about what pattern do you see here on the next?
Haphazardous pattern.
What pattern did you say in this?
Haphazardous pattern.
I didn't hear you. What did you say?
Pattern.
Haphazard pattern. Yes, there's no pattern to be seen at all. Yeah, you see lots of spindle cells, but they are placed in a haphazard pattern. Very good. So that is story form. This is haphazard. Excellent. So now all of you are getting very good at looking at patterns. Yeah. Priyamada, what is this pattern?
Ma'am, it's like world.
Yes, it's world, but it's not story form, is it? No.
No, ma'am.
Oh,
It's a combination of two patterns, ma'am.
all right. What's the two patterns?
And one area it is like fascicular.
Oh yes, you're seeing fascicles. Very good. And I can see the fascicle over here. Excellent. Of course, I can see a fascicle. You can see the fascicle here, and we also see a fascicle here. A fascicle that is sort of running around. Very good. Now, what about the other stuff? Priyamada, what about this huge big thing here? What about this? What about there? What about all the rest of this? Are they spindle cells?
Ma'am, these look like spindle cells only, ma'am. A herringbone pattern is also there, I think.
Herringbone. Where is the herringbone? You see a spine and you see things going off at an angle? I don't think so.
It's a world and
Okay, so you have identified that there are fascicles, and then you see some things which are, not. They probably are fascicles, right? But what has happened to them? Like what we saw. Look at this thing. We saw it where Shashank was saying, no, these are not spindle cells, because he didn't see the spindle nuclei. So why are you not seeing the spindle nuclei over here, Priyamada?
ma'am, these are, I think, transversely cut.
So they're transversely cut. Now in your mind, you should understand that these are all fascicles. Yes, they are all fascicles, but in these particular slides, you are seeing some fascicles that are cut longitudinally, some are cut completely, and some are cut transversely. So what kind of pattern is this, do you think, Priyamada? All the rest, I hope you're thinking. Deepali? Mixed type. Yes, mixed type. Not bad. What? Come on, Deepali.
Sheath, ma'am.
Sheaths. Absolutely right. It's a sheath. And if you know what is a sheath, and there I've shown you a sheath, okay, it is in a crisscross fashion that is forming the sheath. That's why when you cut that sheath across, anywhere, you are going to see this peculiar crisscrossed pattern. So now, if you've never seen a sheath in your life before, a real sheath. Those of you who come from areas outside of Mumbai, we don't see sheaths over here in Mumbai, but in the farming community, etc., that's what you see. You see them, all the straw and other things are all bundled together in a sheath like this. Okay, so that is a sheath. Do you agree, Kedar?
Yes, ma'am.
Yes. So you know what I've been telling you so far, no? That we have to use a two-dimensional picture to make a three-dimensional image. And those of us who can do this well become better histopathologists than those who never even try to make that exercise. Okay, very good. Now this is the other spindle cell pattern that you should be able to recognize. These are spindle cells. These are all running. I'm telling you they're spindle cells, but I've taken it at very low power because I want you to try and identify what is this pattern. Saida, what is this pattern? All these three have the same pattern. They're not all the same lesion, but they all have the same pattern. Yes, what is that pattern, Saida?
The plexiform pattern.
Plexiform. Excellent, Saida. That's very good. Does everybody now agree? Yes, it is. It's a plexus. You know what is a plexus? We have lots of plexuses in our body, and the plexus may be a vascular plexus, it may be a nerve plexus, it may be a plexus of many different things. Okay, and it is a ramifying leash. You know what is a leash? There, I showed it to you on the right. It's like what you have in the cables in your home. You have multiple of these wires. Okay, that are enclosed in some kind of bundle. Okay, so you can see the outlines of the bundles. You can see here also the outlines of the bundle. Yes, you see it in any elongated structure. Once again, doesn't have to be a spindle cell. It can be a plexus of axons. It can be a plexus of nerves. It can be a plexus of blood vessels. All that you need is a long structure. But because spindle cells have an elongated structure, they can also be seen as a plexus. So it's a ramifying leash of elongated bundles of cells or tubular structures such as nerves or blood vessels. Very good, Saida. You have been able to do this. Now, I'm not going to waste a lot of time on this, but just as you have patterns of growth, you have different matrices, and a matrix is an extracellular substance that is in the stroma, because you know that there can be an extracellular substance that is inside a lumen. In that case, we don't call it a matrix. What do we call it, Saida? If you have an extracellular material that is inside a lumen, we don't call it a matrix. What do we call it? Saida, it is extracellular. It's inside a lumen. It is a material. It is not cellular. So what is it? Deepali, what would we call it?
Stroma.
No, if it's inside a lumen, what do we call it? We call it a secretion, right? So when I have any, whether it's a gland or a duct, and there is a secretion inside of it, is that extracellular or not? Yes, a lumen is extracellular. Yes. Okay, so everything that is extracellular, please get it into your head, is not a matrix. The matrix is the extracellular material that is present within the stroma. All right, so that's the definition of a matrix. So here is collagen. Okay, on the left side, and there is mixoid on the right side. I can't go into what is mixoid, etc. now. Here you've got on the left side both collagen and mixoid. On this side you have collagen and osteoid, which is calcifying. So these are all different kinds of matrices. Here you have other matrices. What is this matrix, Elsa, that you're seeing on the left side? Cartilage. Yes, very good. That's a matrix. Okay, cartilage has got both the chondroid matrix as well as the cell, but that is chondroid. Okay, what is this matrix here in the middle? You've got cartilage and osteoid. What is this? Osteoid. Excellent. And what is this? No, it's bone. Yes, it's woven bone. So there are different kind of mesenchymal matrices. Okay. Now we come to the meat of this talk, and that is a spindle cell lesion. What next? How do you approach a spindle cell lesion? How do you analyze it? Okay, the first thing is that you have to make a good observation. Number one, you can't call something a spindle cell if it is not a spindle cell. So you have to make your observation. The observation not only is about the cell, that it is spindle, you have to look at the type of nucleus, you have to see whether the nucleus is bland, does it have mitosis, so you do a lot of cellular observation. Then you have to look at the pattern in which these spindle cells are being arranged. It's also part of your observation. Then obviously that you have to look for the matrix, because when you're looking at spindle cells, you are thinking in terms of a mesenchymal lesion. Everything that's a spindle cell is not necessarily mesenchymal, but that is the most common thing. Okay, so mesenchymal, and if it is mesenchymal, we are talking about stroma, we are talking about matrix. So you to make your observations. Based on those observations, you make an interpretation of what you are seeing. Okay, you see the pattern, you see it's parallel, you say I'm seeing a fascicle, or I'm seeing a palisade, or I'm seeing whatever else, a sheath. These are all interpretations made on the basis of observations. Okay, and then you have to put it into some kind of algorithm or schema. Right? And here is a schema. And I show this to people whether you're doing spindle cells or you're doing any other diagnosis. If you have a schema in your head and you start with, and this clinicians should also be using. Okay, this is something that as a medical student I learned. That's how clinicians do it. Okay, congenital or acquired, whatever I'm looking at. If it's acquired, is it physiological or pathological? If it's pathological, is it neoplastic or non-neoplastic? If it's neoplastic, then you ask yourself, is it benign or malignant? If it is malignant, you ask yourself, is it primary or secondary? If it's benign, you can't ask yourself about primary or secondary. And finally, you come to the diagnosis. If it is non-neoplastic, then there are several alternatives. Is what you're seeing there about cell injury? Is it about repair? Is it about acute or chronic inflammation, vascular disorders, and so on and so forth? Okay, this is how we make any diagnosis, and the same thing applies to spindle cells. Okay. If you have a tumor and you're not sure what you're dealing with, sometimes you have to resort to ancillary techniques. It's not required in every case. In fact, we overuse a lot of immunohistochemistry because we are trying to get over our own lack of confidence. Okay, but that's not a good way to use immunohistochemistry. If you've got good observations, good interpretation, you've done a good analysis, more often than not, you will not need to use immunohistochemistry. Okay, I've given you some markers that are others, and if you need to, you will use a molecular marker. All right, so now we can start with our the cases that I sent you. All right, who wants to take the first case? I'll start with Saida because I've got a list of names and we can go one after the other. Come on, Saida, and this is easy. So come on. There are two lesions and they look similar, right, Saida?
Yes, ma'am.
Yes. So read the history and tell me what you see. Only don't
Middle-aged man with a small lesion on the skin of the nose.
Yes.
Uh,
And that's case 1A. And what is 1B?
1B is a 21-year-old female with a paraumbilical mass involving the skin.
Exactly. So both of them are cutaneous lesions, right?
Yes, ma'am.
Yes, excellent, Saida. Now come on, you describe what you see. Describe what you're seeing. This is fairly low power. So
Ma'am,
we discussed how we have to go about it, right? Yes.
Yes, ma'am.
So observations first.
Ma'am, in the left side of the slide, in the low part shows a bland, small spindle cell in concentric pattern with numerous blood vessels.
Concentric pattern. Now, did we discuss any concentric pattern, Saida? What is a concentric pattern? What is concentric? You know what is concentric pattern? Can you give me an example of a concentric pattern? I can give you. Have you ever seen a Samoma body?
Yes.
You've seen one, Saida?
Yes, ma'am.
Yeah. So what is a Samoma body?
Ma'am, these are concentric lamellated calcification.
Yeah. So you're using the word concentric, right? Yes or no? And you've seen something like that over here, Saida?
No, ma'am.
You know what is concentric? Concentric is this. Yes, there's something that goes completely round. Then there's the next layer that goes completely round. Then there is the next layer that goes completely round. Okay. So now, if you tell me that this looks like that, then I will agree that it is concentric. Is it concentric?
No, ma'am.
No, ma'am. Very good. So now we saw some. You agree that this is spindle, right? You agree, Saida, that it is spindle?
Yes, ma'am.
Oh, very good. So you say no, that it is spindle. It is spindle. The other one is also spindle. Okay. So chalo then. But we have seen the patterns of spindle cells. I showed you all the patterns of spindle cells. So now you tell me, which pattern of spindle cells does this match? So you want me to shout all the patterns one by one? No? Yes? Yes? No. Is it a fascicle now? Saida, you don't want me to do this, right? You don't want to be spoon-fed. So what are the patterns that we discussed? Come on.
Ma'am, fascicles,
herringbone,
storiform, palisade,
yes.
plexiform.
Yes, that is tag on, yes. And plexiform, so hemangiopericytomatous is plexiform. And we have sheaths, right? Yes, so now all of these we have named. Saida, which one is this?
Haphazard pattern.
Haphazard, you really think it's haphazard? All right. Saida, I gave you these pictures, right? Now you're telling me this is haphazard, Saida? Huh?
No, ma'am.
You have seen the pictures.
Storiform.
So then why did you say it was haphazard? It is storiform. Left is storiform, right is storiform. Right is the right-sided picture, that is 1B, is more obviously storiform than the left. But every single one shows you a point there, and you can see the point. Let us see if we can I can get some points to come up over there. All right, I'm going to mark the points from which all this storiform is coming up. Okay, there is the point. Yeah, here is a point. There is a point. You can see the points from which, and what do I mean by the point? The center point from which everything is radiating out. Can you see that now? Maybe I ought to use something that's white. Then you will be able to see. This is the center point. Okay, this is the center point. Here is the center point. You see, all of these are radiating out. If anybody has a problem, you better tell me now. Okay, because this is absolutely storyform. Saida, you have a problem?
No, ma'am.
No, are you sure? Because you've seen this the case before and you were not able to say it was storyform. You said it was haphazard. It is not haphazard. Here are all these points from which, central points from which these things are radiating out. And here you can see this. This was exactly the same case that I showed you before. Yeah, does anybody have a problem? Yeah, Diksha, you have a problem?
No, ma'am.
No, ma'am. Anybody has a problem with storyform? In the chat box, is anybody saying that they have a problem? I hope not, because this is as storyform as you can get. Okay? We look at it. Now you can see this entire part. There you have that central point from which, look at this beautiful storyform. Here, everywhere. This is much more storyform, but one is less storyform than the other. But this is storyform. Okay? So now what do we have? We have two storyform lesions. Both are in the skin. Yes? So case 1A and 1B. Saida, do you agree with this? They are skin lesions. Both are skin lesions. Both have a pronounced storyform pattern. I didn't show you the edges, but I'm telling you that the edges are irregular. Okay? So now we have to do some thinking. Okay? So what is it? There are only two differential diagnoses. Now, what differential diagnosis did you come up with, Saida?
Ma'am, case 1B is ma'am dermatofibrosarcoma.
I see. Okay. And 1A?
1A is ma'am dermatofibroma.
Why? Because I can't show you two dermatofibrosarcomas? What? And why did you think that 1B is a dermatofibrosarcoma? What was your reason for calling it a dermatofibrosarcoma? Saida, you have to give me a reason. Let me ask somebody else. Deepali.
Only dermis is involved.
Dermis is involved. So?
The dermal tumor.
So what? That's why it's a dermatofibrosarcoma. Somebody in the chat box is saying irregular edges. Oh, okay. Come on, Elsa. What was your diagnosis on 1A and 1B?
Ma'am, 1A I think it's dermatofibroma and 1B could be dermatofibrosarcoma. Because the morphology of the spindle cells are a little bit different. In 1B we have seen this slender, thin spindle cells.
Okay. And in 1A?
1A most plump spindle cells, and I think that's background.
All right. So you think that 1A is a dermatofibroma and 1B is a dermatofibrosarcoma, and you say that because number 2 is much cellular and it has finer or thin kind of nuclei. All right. What about Priyamada? What is your diagnosis?
Ma'am, is dermatofibroma, ma'am, but I also thought of deep fibrous histiocytoma.
Deep fibrous histiocytoma. For what? On 1B or 1A?
A. Ma'am, and 1B I thought of perineuroma.
Perineurioma. Oh, okay. Aditi? Aditi? Oh, she's not there. Maybe. Diksha? I asked you.
Fibroma.
Oh, dermatofibroma. Which one? A or B?
Ma'am, 1B is clear because it is well circumscribed and dermal based, though we cannot see the infiltrative edges.
Okay. So do you think anything in the dermis is ever well circumscribed? You've ever seen or you heard of a storyform lesion that is well circumscribed? No, the edges are always irregular. Okay, so it's not nothing to do with circumscription. All right. Yeah, okay. Yes, tell me.
1B is dermatofibrosarcoma because there is infiltration in the subcutaneous.
Infiltration into subcutaneous tissue. Achha. Somebody just said no, deep. You said no, that it was a deep fibrous histiocytoma. Did you say? I don't know who said. Shashank?
I told, ma'am. I told for 1A, ma'am.
You thought it for 1A. All right. Deep. Okay. Yeah, Shashank? Shashank is not there. Okay, Kedar?
Ma'am, I thought of these two entities as well.
You thought of two
Dermatofibroma for
entities.
1A.
So now, these are the only two entities which will have a pronounced storyform appearance. What is the fibrous histiocytoma? If you're going to call it benign, it's nothing but a dermatofibroma. Okay, that's another name for a dermatofibroma. So these days we don't use the fibrous histiocytoma word has been deleted from most textbooks because nobody understood what was this fibrous histiocytoma. Is there any such thing as a fibrous histiocytoma? It was a word that was coined and it is now deleted. So there are only two possible diagnoses and nothing else. Okay, now how do we go about it? And the answer is simply this: you cannot tell a dermatofibroma or let me put it this way, a cellular dermatofibroma from a dermatofibrosarcoma. If it is very large, if it is very infiltrative, it is full of mitoses, then yes, you can call something that is storyform and in the skin a dermatofibrosarcoma. Otherwise, you cannot do it. So this is one of those two things that is so simple. You make all the observations that are required, and we have made all the observations. Okay, that it's in the skin, it is storyform, the edges are irregular. Okay, and the age doesn't matter, nothing matters. You have to resort to immunohistochemistry. You can make a guess, and some of you have made a guess. Okay, and I call those an educated guess. Something that is very cellular. You are unlikely to want to call a benign lesion. Okay, but this is not something that you should take your chances on. This is something where you need to do immunohistochemistry. And there are 4 major immunohistochemistry markers, which if you are going to investigate any spindle cell tumor, for that matter, any mesenchymal tumor, you cannot afford to miss one of these 4 markers. And what is that? SMA, which is smooth muscle actin, desmin, S100 protein, and CD34. Okay, and now you see what is the difference between the CD34 expression in a dermatofibroma versus a dermatofibrosarcoma. Because this on the left-hand side is a dermatofibroma. It is always CD34 negative. If you get a storyform lesion in the skin and it is CD34 positive, there is no other diagnosis. It is a dermatofibrosarcoma, right? However bland it might look, however less cellular it is, if it is CD34 positive, it is a dermatofibrosarcoma. All right. So this is something that I would not hazard a guess on when we have a lesion in the skin. This is one area in which I would suggest that at least, even if you don't do SMA, desmin, and S100 protein, you do a CD34. And if that CD34 is positive, it is a dermatofibrosarcoma. If it has, of course, a storiform appearance and it is in the skin. Now, that's a message that I hope you have got across. All right, so now, who's going to do number 2? Come on, Deepali, you're the next on my list.
Also on the lateral border of the tongue of an adult.
Very good. So, what are you saying, Deepali? Quickly, you just have to tell me.
Yes, ma'am. This is, ma'am, section show surface ulceration, base of ulcer show granulation tissue containing the.
1 minute. What is showing granulation tissue? The base of the ulcer. Yeah, can you
Yeah.
show me where is the base of the ulcer, please, Deepali? Ask for annotation. Good. Now show me the base of the ulcer.
Yes, ma'am.
Take the pen, take a nice thick stick.
And this is the base of ulcer.
Where is it? I
Here.
can't see. Where have you drawn the base of the ulcer? I can't see it. Can anybody see it? It may be very, very thin. Take the second pen, Deepali. There are 2
Okay.
pens. Take the second pen, then you will get a color, right? And the color,
Yeah.
choose any color that you want, but go down
This-
and press the biggest.
This is of ulcer.
There. Okay, you've drawn something here. Now I know what you're trying to show.
Yeah.
Yes.
Ma'am, this is the
You're
base
saying
of
that
ulcer.
this is the base of the ulcer. Yes, Deepali?
Yeah, yeah.
Okay.
Continue.
1 minute. You are calling this the base of the ulcer. Elsa,
Ma'am,
is this the base of the ulcer?
sorry, ma'am. This is the sorry, ma'am. This one is the base of ulcer.
Which is the base of the ulcer?
This one. This.
Yeah. Oh, here now. You've drawn something here. This is the base of the ulcer.
Yeah, and this is the surface of the ulcer.
Elsa, do you think that either of these is the base of the ulcer?
No, ma'am.
No. So now you ask for annotation. Show me where is the base of the ulcer.
Ma'am, should I?
Where is the base of the ulcer?
Ma'am, this is the base of ulcer.
Where? Sorry, where is it? What color are you using?
Red.
Red. So where? So this is the base of the ulcer. So let me so everybody can see. This, according to Elsa, is the base of the ulcer.
Not,
All right.
not,
Huh? All right, Priyamada, where is the base of the ulcer?
Ma'am, this is the base of the ulcer.
What color are you using?
So,
You don't have annotation. You haven't asked me for annotation.
ma'am, send request.
Okay.
Can I-
Now come on, where is the base of the ulcer?
Ma'am, the base of the ulcer is here. Ma'am.
Here, where? Show me what color are you using?
Color.
Oh, there. Acha, she's used this on top. Is this what you're saying? Is the base of the ulcer?
Yeah,
Yes,
this
Priyamada? What have
this
you
one.
drawn now?
This one, ma'am. This one.
Where? This?
Ma'am, 1 minute. I'll use the
That's
color.
what you've done. I know what you've done, Priyamada, because your name comes up. Here, yes, I know. That's
Yes,
what you're
ma'am.
saying is the base of the ulcer. All right,
Yes,
let's ask somebody else. Who's there? Aditi, show me the base of the ulcer.
Mama, send the request for
Yeah,
annotation.
come on.
Ma'am, this.
Where is it? Acha, you're doing a lot of. Yeah, I know. She did it here, but you did it with the disappearing pen. Let's use the second pen.
Ma'am, only getting 1 pen option.
No, there are 2 pens. There is one. The second one.
Yes, ma'am. I'm doing one with this.
So you've done exactly where somebody has scored, that is ulcer.
Yes,
Yes,
ma'am.
you've done it there, right?
no, yes, ma'am.
Yes. Okay, so you've done it there. Okay, Chandana. Do you agree with any one of these?
Ma'am, can I try?
Ooh, now Vipali suddenly wants to come back again.
Yeah.
No, wait 1 minute. Please let Chandana do it.
Okay.
Ma'am, I think this is the base of ulcer.
Which one, Chandana? What color are you using?
Pink color, ma'am.
Pink. Okay, so where is it? I can't see your pink. Can anybody see it? Can you see it? Are you maybe use the second pen?
I'm right below Priyambada.
Right below Priyamada.
Yeah, there's a pink line in the center. It
Pink
disappeared.
line in the center. All right. So you've done the same. Shashank, I don't think he can do it because he's on a phone. And I don't know if he's there. Kedar,
Yes, ma'am.
come on, where is the base of the ulcer?
Red ink, ma'am.
Red ink. Oh, so he's here. Right here on top. Okay. Somebody was missed out. Who's it? Diksha? Diksha, did you do?
Ma'am, I think base of an ulcer is a gross banding and on
It's a gross finding. Sure. So you don't want to draw. Now all of you who have done it are all done the wrong thing. Okay. Do you know what the ulcers? What are the different parts of an ulcer? What you see from the top is the floor of the ulcer. That is the floor of the ulcer. Oh God, I did the wrong. I myself took the wrong thing. What's it? Yes, this is the floor of the ulcer. Whatever you are seeing from the top with a bird's eye view, that is the floor of the ulcer. Okay. Then you have what is called a margin or edge, which you can't see in this picture because it's at the periphery of the ulcer. Yes, and the margins are sharp. They may be rolled, and people use margin and edge more or less interchangeably. There is a difference, but you know what is the edge at the base? The base is not even seen in this picture because the base is where the part of the of this ulcer which is resting on normal tissue. That's the base. Okay, so that's the floor. This is all the inflammatory stuff, and at the base, and we will see the base in a minute. Okay, so now that what all of you were showing me, and then they were showing all of this. There's no base there. The base is still to come, which you have not seen in this. But now, who was describing this? Deepali, you were describing it. Yeah. So now, what do you see here? We're doing a seminar on spindle cells, right? Do you see spindle cells?
No, ma'am. Here, proliferating capillaries and fibroblasts are seen.
Proliferating capillaries and fibroblasts. If you are able to see fibroblasts, my dear girl, then you are looking at spindle cells. So can you see?
Come here.
No. So what are you seeing here? All that you're seeing over here is, and we can see it at higher power, but you can see there is fibrin everywhere. What you're seeing is like a network of this pink stuff is fibrin. And caught up in that fibrin, you are seeing inflammatory cells. And what inflammatory cells in an acute inflammation, what do you see? You are seeing neutrophils that are caught up in fibrin. What are you seeing here? There is another layer that you're seeing. So you have the floor, which is looking blue because it is being digested with the amylase. Gosh, there is a lot of enzymes in your saliva, and they digest whatever is there in the floor of the ulcer. Okay. Then you have another layer, which is fibrin. You just see the network, it is fibrin. And in that fibrin, there is this neutrophils that are caught up. Then comes a third layer. You can see these layers so beautifully. What are these? You actually see this pink stuff that is surrounding the blood vessels, and that also is fibrin. Okay, and this fibrin is coming out of leaky blood vessels. Now, those leaky blood vessels are obviously capillaries, which are new formed capillaries. And so it's leaking fibrin, and that fibrin is coming out of the capillaries, and along with it, you are seeing the polymorphonucleocytes. Okay, there are more mature capillaries that are being seen at the base, at the base of this particular section. Okay, see that so clearly. You see it. Well, please, all of you, mute yourselves, because I think that someone has got a problem and we're getting... okay, so here you have the floor, which has been digested by the enzymes in saliva. Here is your fibrinous exudate. Here are your leaky blood vessels. Okay, here is a much more mature capillary network that is there. And now, for the first time, you are beginning to see the base of the ulcer. Okay, so let's start from the top. You see this blue thing, which is... And there are no spindle cells. Okay, these are all... You see the fibrin network in which the neutrophils are there, and you see this leaky stuff that is there, and now you see the base of this ulcer. And this base, which is the interface between the abnormal tissue and the normal tissue, for the first time, you are beginning to see spindle cells. Can you see spindle cells now, Deepali?
Yes, ma'am.
Yes, and these are fibroblasts. There you're seeing the fibroblasts that are at the base of the ulcer. Okay, you're also seeing some other spindle cells over here. Can anybody identify them?
Belong to endothelials.
Yes, endothelial cells. All endothelial cells are spindle cells. So in granulation tissue, you're going to see some fibroblasts, and you are going to see endothelial cells. Now, I want to ask somebody over there, Kedar, what are you seeing in this particular blood vessel? What are you seeing in this particular blood vessel? You can see a blood vessel, right? Yeah, Kedar? As Kedar disappears? What? Has Kedar disappeared? Oh, Kedar is not there. Okay.
Sorry, ma'am, I was muted. I'm sorry.
Oh, sorry. Okay. Kedar,
Uh,
what are you seeing in this blood vessel?
Inside the lumen of the central blood vessel, I can see neutrophils.
Very good. So am I just crazy that I'm asking you to notice that they are neutrophils? What is this phenomenon?
A feature of inflammation, ma'am.
Picture of
Associated with
inflammation. Acha. Okay. Chandana, what is it?
Diabetes, no?
Diabetes. Chandana, diabetes is the neutrophils coming out of the lumen of the vessels. They're all sitting in the lumen over here. Diksha, what is it? Huh? What is it? Diksha, okay. Aditi. Aditi,
ma'am,
what is it?
margination, rolling, adhesion, those phenomena.
So now, Kedar, you recognize that this is margination of leukocytes. Okay. Have you ever seen margination of leukocytes before, Kedar?
No.
Yes or no?
No.
No. It's there, but you have never noticed it. Okay. None of the students that there in every inflammatory condition, you will see margination of leukocytes, but nobody notices it. That's not the reason I put this up. Okay, this is granulation tissue, and you're seeing a lot of spindle cells. You're seeing them in the blood vessels. You're also seeing them at the bottom where there is fibrous tissue, which you're seeing over here. So there are spindle cells. So what is this case? What is this ulcer all about? All right, here is the definition of that ulcer. I kept it there because you have to be able to see spindle cells wherever they occur. Okay, so you've got the 3, maybe 4 layers, partially digested acute fibrinous exudate. Then there's leaky vessels with an acute fibrinous exudate. There is mature granulation tissue, and there is fibrosis in the base of the ulcer. So note that this is the floor of the ulcer, and the base is down here. Okay, the rest of it is all parts of. Again, we have got this. Okay, all right. The diagnosis is that this is a chronic traumatic ulcer. All right. So now let's come to case 2B. Is this case 2B? Yes. Very good. Who's going to take this now? Elsa? You there, Elsa? Are you there, Elsa?
Yes, ma'am.
Come on.
Ma'am, yes, muted. It's a case of a 64-year-old female with soft cystic mobile swelling on the forearm growing rapidly over a period of 1 month with a size of 2.5 centimeters.
Very good. All right, now. You've seen all this, right, Elsa? Yeah, this is the low power view. All right.
Ma'am,
Anything that you want to say, low power?
Ma'am, I can see the slides and it's like the history. Yes, ma'am.
Has it not moved for anybody? Has it moved for other people?
Yes.
Yeah, it has moved.
Now I can see. Yes, ma'am. Now I can see. Yes,
All
ma'am.
right, Elsa, come on. Your internet is unstable. Yeah, tell me.
Ma'am, section
What do
shows.
you want to say at low power? Just your general impression at low power. What do you see?
Ma'am, nodule separated by a cellular lesion.
Yes, so you have nodules. Very good. Excellent. You have nodules. And the nodules are what? What do they look like? What is the color of the nodules as compared to what is there in the center? The nodules are at the periphery, right?
Yes, ma'am. Very sophilic compared to the septate.
Yeah, so these nodules are pale staining, and we would say that there is collagen here, and there seems to be some kind of mixoid change in the nodules. Yes, Elsa? Excellent. Yeah. Here's the next bit. What does it show you?
Ma'am, the lesion is infiltrating the adjacent fat.
Yeah, so there is an infiltration into the adjacent adipose tissue, and you can see that there is a mixoid matrix. All right, very good. Now come on, describe this.
Ma'am,
What is the principal cell that you are seeing?
spindle
Just
shaped
look
cells, ma'am.
Huh? Sorry?
Spindle
Spindle shaped cells. Okay. You said spindle shaped cells. Yeah. What about here?
cells.
Spindle shaped cells?
Ma'am,
You see collagen, yes. But we're talking about cells. There is
Yes.
collagen, there is mixoid, but we're talking about the cells. So describe the cell. What are you seeing? What is the principal cell over here?
there are also cellulite cells.
There are what cells?
stellate cells.
Stellate cells. So you have got two kinds of cells, Elsa. That's excellent. You've got spindle cells and you have got stellate cells. And those who have not seen stellate cells in their lives, please see stellate cells now. These are all stellate cells. They do not have spindle nuclei. So full marks to you, Elsa. You have noticed that there are definitely spindle cells. You see, these are spindle cells. That's a spindle cell. But there are lots of stellate cells. Excellent. Here is another part of this lesion. It looks infiltrative into adipose tissue. And there seems to be an edge over here with something in it. Okay. What is that thing in it, Elsa? What is this?
Collagenous.
What is all this? Material. It's extracellular material. What is it?
Fibrinous material.
It is fibrinous material. Very good. So you have fibrinous material and it is bordered by this cellular tissue. And what is the cellular tissue made up of, Elsa?
Ma'am,
What is the principal cell that you are seeing over here?
ma'am, the stellate cells and extracellular
Stellate
cells.
cells. Yes, absolutely. Absolutely. The stellate cell that is the principal cell that you're seeing over here. So we have a lesion in which you have mainly stellate cells and very few spindle cells. Look at the stellate cells. Anybody has an issue with stellate cells, please note that the cells may have long processes and they're also in mitoses, but look at the shape of the nuclei. The shape of the nuclei is very irregular and the cells also have got multiple poles to the nuclei. So please, this you have to imprint in your minds as being stellate. There is huge numbers of stellate cells. So what is a stellate cell? Look at them. They're all over the place. So what do you think is the stellate cell, Elsa? What is the stellate cell? Let me see.
Fibroblast.
What is it, Elsa?
Myofibroblast.
Myofibroblast. Because if they were fibroblasts, they would look like the cells over there at the top. Can you see? Yes. So these are fibroblasts. Okay. But all of these stellate cells are myofibroblasts. So this, for all practical purposes, is not a lesion that is composed only of spindle cells. Okay. So when I notice that this is an infiltrative lesion, yeah, and it is composed to, we have to identify the principal cell, which you have already identified, which is a myofibroblast, is a stellate cell, and you can see it. And the other features we noticed were that it was nodular, it was a well-defined lesion, but with infiltrative edges. And when we talk about well-defined, it's not the opposite of infiltrative. Okay, it can be circumscribed and still infiltrative. It had a central fibrinous area. You notice something else, there were virtually no inflammatory cells, but extravasated RBCs, plenty. Okay, and there was loose connective tissue, irregularly placed collagen. And when I say loose connective tissue, there was myxoid. And there was a myxoid matrix as well. So what is this? What's the diagnosis now, Elsa?
Nodular fasciitis.
Nodular fasciitis. Very good. That's excellent. If you have to use an analysis chart, what do you do? Which is the most crucial decision on this decision chart, Elsa?
Neoplastic or non-neoplastic?
Yes, neoplastic or non-neoplastic. Right. So now, which do you think it is?
It's a neoplastic.
It is neoplastic. Okay. Because nodular fasciitis is neoplastic. Is that it, Elsa?
It's a benign.
It's benign. Yes, but is it neoplastic?
Once a reaction to the
If it is non-neoplastic, then we have to assume that it is a reactive proliferation. If it is neoplastic, we have to call it some name, no, like myofibroblastoma or myofibrosarcoma. But you used a term and you were absolutely right. And how did you come to this diagnosis, Elsa? Would you like to tell us? What did you use to come to this diagnosis, which was excellent?
there's
I've given you all the features over here. So what features did you use to reach this diagnosis?
the morphology of the
Yes.
lesion. It consists of stellate cells as well as spindle cells.
Yes.
And there was extravasated RBCs, and the lesion was also infiltrating the adjacent fat.
So why isn't it a sarcoma or a myofibroblastoma or something of that sort? What tells
Ma'am,
you that this is a benign lesion which you call nodular fasciitis?
And there was no atypia and increased mitosis.
There was no atypia. My God.
Yeah,
Really?
ma'am, and no mitosis.
Mitosis. I just showed you mitoses in this lesion. There were mitoses. So what did you use? Anybody else thought it was nodular fasciitis? Priyamada, what did you think? Priyamada, are you there? Maybe not. Aditi, are you there?
Hello. Yes, ma'am.
What did you think?
Ma'am, I also thought of nodular fasciitis, ma'am.
Okay.
Ma'am, I too thought of nodular fasciitis.
Okay, so how did you make the diagnosis? Based on the features that you're seeing here?
And first of all, because of the history, ma'am,
What
rapidly
is
growing.
the history?
It's a rapidly growing.
Excellent, Priyamada. That is what makes this lesion a benign nodular fasciitis, because it had a short duration and rapid growth. It's full of mitoses, it's got infiltration, it's got atypia, it's got all sorts of things. But because it has a short history and rapid growth, and it has reached a size of 2 centimeters, literally in the period of a month, there is no malignant tumor that grows like that. And if there was a malignant tumor that grows like that, it would be very obviously a malignant. Okay, so this is nodular fasciitis. Now you notice that I not put it in either neoplastic or non-neoplastic, because we really honestly don't know. A lot of people believe that it is neoplastic. Why? Because there happens to be an activation of this USP6 gene. Okay, there are gene fusions, etc. And people now believe that, okay, you have a gene fusion, then therefore that thing is a neoplasm. And I don't think that that necessarily makes sense. If you are of the school of thought that says that if you have a molecular abnormality, therefore it is neoplastic, then there are lots of people who have molecular abnormalities, and like you have hemophilia, and don't tell me that that person is neoplastic. Okay, so I think we have to be careful about using clonality as a way of suggesting that something is neoplastic or not. All right, very good. Now what I want you to understand is simply this. Okay, this is a post-lumpectomy scar in the breast, and this is the nodular lesion. This is another nodular lesion on the arm, and I want you people to look at the similarities between the two. There is good similarity between a young scar and nodular fasciitis. Okay, so one has to be a little, when you are looking at scars, when you know that they are scars, like when after a lumpectomy, just don't brush that off and say, oh, there's no tumor seen at the lumpectomy site. Look at a scar, and very often a lumpectomy is done within 3 weeks of a biopsy. A mastectomy is done within 3 weeks of a lumpectomy, and you will be able to see such beautiful scar tissue. And that nodular fasciitis resembles that kind of scar tissue. Now, when you come to the other end of the spectrum, that is desmoid fibromatosis. This is a well-healed scar on the right-hand side, and this is desmoid fibromatosis. And you look at the two, and honest to goodness, you can't tell the difference unless you know that something is forming a mass. Histologically, there is no difference on H&E between a desmoid fibromatosis and a well-healed scar. So if you want to study what desmoid fibromatosis looks like, you've never seen it before, go and look at a well-healed scar. Of course, people use beta-catenin and other things. All right, this just tells you that these are all myofibroblasts. Okay, you may have some spindle cells there, and sometimes when you have a really late scar, you have more spindle cells because they're all fibroblasts at that time. All right, good. Who wants to take 3A? Who's next now? Does Aditi want to take this? Come on, Aditi. Is Aditi there? Oh, she's dropped out. Maybe she's dropped out. Okay, Diksha, are you there? Hi, Diksha, are you there?
Yes, ma'am.
Come on then. Come on, Diksha.
Ma'am, cyst is a gastrohepatic region.
Yes, very good. Come on, say something about this, Diksha. You've got the history, and this
Yes,
is. Do you think it's a tumor or not a tumor?
Yes, ma'am. Tumor.
Tumor. Is it a cyst or not?
Yes, ma'am. Cystic spaces are there on the top and the solid at the base above the hemorrhagic area.
All right. So, do you think that this tumor is solid or is it cystic? Solid or is it cystic?
Ma'am, cystic with some solid areas.
Cystic with some solid areas. Okay. So, is it something like what you see in the ovary when you see a cystadenoma or you see a cystadenocarcinoma? Is it that kind of cystic change or what?
Ma'am, solid with a cystic degeneration. Sorry.
Cystic degeneration. Okay. Now we come to cystic degeneration. All right. Come on. What are you seeing here now? This is the solid area, right?
Yes, ma'am.
Okay.
Palisading.
Yes. So you are seeing. Very good. Yes, Diksha. What are you seeing?
Palisading of tumor cells.
Yes. So it is a spindle cell. It's a solid spindle cell tumor with palisading of the nuclei. Yes.
Yes,
Obviously, they're tumor cells, but you can see very nice palisading of the nuclei. Yeah, you can see that. It's beautiful. Okay. So why do you think there is cyst formation happening?
Degenerative change.
Degeneration. What is degeneration, Diksha?
Long-standing cases, they may show a degenerative change or hyalinization or calcifications.
Okay. So you think that this is there such a, you have a definition for degeneration? What is degeneration? What is actually happening over here? What's happening to the cells?
Cells are
What's happening to them?
seen to be merging in the myxoid.
So you think that there is a myxoid change over here? Or do you think that these cells are undergoing apoptosis? What? So what do we mean by degeneration? Yeah. Do you think degeneration means that there is a lot of edema in this particular, that there is a lot of fluid that is collecting over there? And where is the fluid coming from? Or number two, maybe the cells are undergoing apoptosis, and the space that was occupied by those cells is now, left as a cystic space. So what do you think is happening? Because all of you just talk degeneration. Have you ever thought, Diksha, what is degeneration? No, we just use that term. So you have to think as to what exactly is degeneration. But these are not true cysts. That is for certain, right? There is space in between the solid parts of the tumor. And if you look carefully, you can see that these cells are undergoing apoptosis. You see how small and dense these nuclei are? That is because so there is apoptosis in this tumor. Okay. And you can see that. You see there's a lot of fluid that is collecting in the spaces that have been formed from the dropout of these spaces that have been formed from the dropout of these cells. And you see there is spaces that are forming in between these cells as well. Okay, so there is a lot of edema, there is spaces, and there is apoptosis that is going on in this tumor. Excellent. And you notice the palisading. So now, come on, tell me. Is this a spindle cell tumor?
Yes, ma'am.
Very good. What is the pattern?
Palisading.
Yes, it is pseudocystic and palisaded. You have to notice that this is pseudocystic. Yeah, it is pseudocystic and palisaded. So now what next? What next? So you've seen the spindle cells, you've seen that they are pseudocystic and palisaded. Now we have to come to some interpretation. Yes? Interpretation means what? We have to think of possibilities. So what are the possibilities?
Ma'am, considering the static thinking about a gastrointestinal stromal tumor.
Very good, Diksha. See, you have three. You have a neurogenic tumor, a smooth muscle tumor, and you have something else. Okay, I'm happy that you thought of a gastrointestinal stromal tumor, because if you look at the history, okay, what neurogenic tumor is going to form a cyst in the gastrohepatic ligament? Okay, yes, there may be a smooth muscle tumor in the gastrohepatic ligament, but when you're talking about the history, and the history tells you that there is a gastrohepatic cyst, then something else has to come into the differential diagnosis, and that is what you just said, which is very good, a gastrointestinal stromal tumor. Now, so which of these three would you want to make an educated guess on H&E? Now, which of these three? Normally, you have a neurogenic tumor like a schwannoma that is palisaded. Yes?
Yes.
Okay. So are you going to rule a schwannoma out?
Schwannoma.
It's
Yes,
palisaded,
ma'am.
isn't it? And that also shows you cystic change. That also shows you areas where the cells become vacuolated. So are you ruling it out? Or which of these three are you giving most weightage to? Anybody doing anything in the chat box?
Neurogenic and gestational keep.
Sorry, what are they saying in the chat box? Neurogenic. Okay, but Diksha, you said gastrointestinal stromal tumor. So if you had to do an educated guess, it would be gastrointestinal tumor, because what is most common that will give you palisading, etc. Yes, and be present in the gastrohepatic space. It would be a gastrointestinal stromal tumor. So I think your guess was a good guess. So how would we prove this? How would we prove this?
Ma'am, IHC,
Immunohistochemistry. All right. So what immunohistochemistry?
ma'am, C-kit and dog one.
C-kit and dog one. So straight away you want to C-kit and dog one. Yes. Do you want to do anything else? Sure.
Ma'am, these are more specific.
And suppose it turned out to be negative for C-kit and dog one. Then what would you do?
S100.
Then you would do S100. What did I tell you when you are investigating any mesenchymal tumor? What should you do? What should you do? You should do for
SMA.
right? Yes. So SMA, S100, because you thought of gastrointestinal stromal tumor, you should add CD1 dog stromal tumor. Okay. Dog one. We got so much echo today. So here you are. Here is your gastrointestinal stromal tumor. We don't want to read this immunohistochemistry picture. What do you see from left to right, first row and bottom row?
Ma'am,
Yes.
SMA
Is it positive or negative?
negative,
Negative. Then what are all those brown things over there?
focally positive.
Oh yes, it is positive, and it is focally positive. Okay, it's not weakly positive. It is focally positive. If I can see it at this far and I can see that it is brown, it is focally positive. Okay, tell me about Desmond.
Negative.
And S of protein.
That is also negative.
All right. And what is positive?
CD34, CD117, and dog one positive.
All right. So what is CD117?
Ma'am, C-kit only.
C-kit.
Proton protein.
Yes, I don't know that, but it is essentially it is the CD name for C-kit.
Cluster of differentiation.
So what is dog one? What is this dog business?
Ma'am, it was found on the.
Yes, discovered on
Discovered.
chest. Okay,
Chest, yes.
that's why it is called dog one. So very good. So the diagnosis was gastrointestinal stromal tumor, and it's not uncommon for a gastrointestinal stromal tumor to show palisading and to be cystic. Okay, these are not true cysts; they are pseudocystic tumors. So one should be aware that this is one of the issues. Okay, so what is the lesson that we learned, Diksha? We learned that palisades are not exclusively seen in neurogenic tumors. They are seen not uncommonly in GISTs and in smooth muscle tumors. Okay, very good. All right, now who's going to do the next one? Any questions that I can answer? Okay, Chandana, are you there? You're there? Anyway, you didn't get this thing. I just wanted to present this case. You don't have to answer the questions. But this was a 68-year-old male who had a right inguinal orchidectomy for multiple palpable nodules along the spermatic cord. And they were seen on ultrasound. He could feel it, and then he had an ultrasound. Okay. And on sectioning, there were all these. They sent us the testes because he had an orchidectomy, and the testicular parenchyma was absolutely normal, and there were multiple firm white nodules, as you see over here. Okay, you see the nodules. These were along the spermatic cord. And here you see these nodules. You see this nice capsule over here, and these are the nodules. Is this a spindle cell lesion, Chandana?
Yes, ma'am, looking like spindle cell lesion.
It is a spindle cell lesion. Okay. You want to say anything about this spindle cell lesion? What is the
Yes, ma'am.
pattern in which the spindle cells are growing?
It's looking like herringbone pattern.
Herringbone pattern. They are in fascicles, right? Okay. There really is no herringbone pattern. You don't see. If you think that this is a herringbone pattern, it is not, because these are all cut obliquely or transversely. So they're not spinning off it like you see spindle cells like ribs. So there is no herringbone pattern. This is fascicles. If you want to say that they may be in sheaths, I will agree, because these are fascicles that are cut in many different directions. Okay. Here is a spindle. This is a spindle cell tumor, without a doubt. Anything you want to say about the cytoplasm of this?
Abundant.
Abundant.
Abundant cytoplasm.
It's abundant. Is there anything else that you want to say?
Yes, it's not finished.
It's deeply eosinophilic. It's very pink. Yes. And once again, please see how you have fascicles and some of them are cut obliquely or transversely. And that's why you get areas where they look as if the nuclei are round. All right. Anything else you want to say about the nuclei now at high power? What sort of nuclei are these? Are they pointed? Are they cigar-shaped nuclei? All right. So we have blunt-ended nuclei. Yeah. That's most of them are blunt-ended nuclei. Okay. So now what is your diagnosis, Chandana? Is this spindle?
It is spindle cell.
All right. This is spindle. What is the pattern?
Fascicular pattern.
Yes, it is in fascicles. All right, good. What next do you want to do? When you see fascicles and it is spindle and you have this history, what are you thinking about? And you have these very pink eosinophilic cells. What is coming to your mind? Huh? Come on. Is there any diagnosis that you're thinking of? You have to think of some possibilities. So what possibilities are coming to your mind, Chandana? We even said they are cigar-shaped nuclei, etc. Yes?
Smooth muscle tumor.
Smooth muscle tumor. Very good. So it's a smooth muscle tumor is the first thing that comes to your mind. Yeah, down the list would be a neurogenic tumor. Yeah, because there are multiple nodules. Okay. So anything else that you're thinking of? Please, I cannot think of anything else. Did you think of anything else? No. Okay. Right. So now we go to the history. And what does the history say? Multiple nodules in the spermatic cord. So now tell me, you have multiple nodules in the spermatic cord. So what is it likely to be? Yeah, Chandana? Do smooth muscle tumors occur as multiple nodules? Have you heard of such a thing? Yes? Anytime, Chandana? You're a third year student, right?
Yes, ma'am. Yes, ma'am.
Yeah. So do you get multiple nodules at any time? Have you heard of a term called leiomyomatosis?
Yes, ma'am.
Yeah. So where do you get that?
Yes, ma'am. It can occur in
Yeah, they occur in females, right? And when you get
Yes, ma'am.
multiple leiomyomas, and then they might seed the peritoneum, and you get leiomyomatosis. Yes, Chandana?
Yes,
Is it
ma'am. Yes,
possible
ma'am.
that this is leiomyomatosis only that it is occurring in a male?
Possibility.
There is a possibility,
Possibility.
right? So if
Yes,
you had to make an educated guess on H&E, what would you say? Leiomyomatosis of the spermatic cord. Yes, that is one of the things that you will think about. Okay, so how would we prove this? What should we do?
I had SMA for
Yes, so we should do immunohistochemistry, and what would we want to do? We should do,
SMA.
yes.
Desmond is negative. SMA will be negative.
Yeah, so SMA was very strongly positive. For some reason, whoever looked at this case did not do a CD34. Okay, so they did SMA, and the diagnosis was in their minds multiple nodules, leiomyomatosis. So what was the diagnosis that was finally given? The diagnosis made was leiomyomatosis. Okay, but that was not the end of the story. This patient came back 12 months later because he was losing weight. All right, and when the ultrasound of the abdomen was done, they found multiple microechoic nodules right throughout the peritoneal cavity. And one of the nodules from the rectovesical pouch was biopsied under CT guidance. So now what do you think? What do you think, Chandana? Here is what it looked like. Is this spindle shaped? This is a spindle cell tumor, right?
Yes, ma'am.
The needle core biopsy, yes. Is this also a spindle cell tumor? Yes, it is spindle cell.
Yes, ma'am. It is also spindle cell.
Does it look like the tumor that was there in the spermatic cord?
No, ma'am.
It doesn't look like the tumor in the spermatic cord. What do you mean? It's not spindle. It doesn't have blunt edges, of the nuclei. It does, right? Okay, so it is, because now the patient can have many different kinds of tumors, so it's the same. So now what are we going to call this? What are we going to call this? Peritoneal leiomyomatosis. What do you think, Chandana? It happens, no? It happens in females. So maybe it's happened in this male as well. But you remember that we had made a mistake. Okay, what was the mistake? We did the SMA. Yes, we did a desmin. We did the S100 protein. It was negative. Okay, but the last time we had not done a CD34. Okay? So is it enough to do S100 protein? To do SMA, desmin, and S100 protein? And the answer is no. So sometimes if you do not get a desmin, then you do an HCAL desmin. So somebody was looking at this said, "Chalo, let's do an HCAL desmin," and that is also negative. So now there was no choice. One had to do a CD34. Now tell me, Chandana, is it positive or negative?
Positive, ma'am.
Yes, it is focally positive. All the cells are not positive, but there are cells that are positive. So now what, Chandana? Now what should we be doing? Now what should we do? Somebody in the chat box, Vishal, says do CD117. And Vishal is absolutely right. Okay, here is C-KIT, which is CD117. And here is DOG1. Whereas CD34 was very focal in that tumor. Look at CD117 and look at C-KIT. Okay, so we went back to the spermatic cord tumor and did CD117 and DOG1 on that tumor. And you see that they are both positive. Okay, CD34 is also positive in this. So here's 34, and there is C-KIT on that tumor. Okay, so what is this case now? Instead of leiomyomatosis, this is a gystosis. In other words, it's a gastrointestinal stomatosis of the spermatic cord with peritoneal dissemination. And I think that this was a tragedy. Of course, the patient is still alive because he is on Gleevec. But this should not have happened. We should have, if we had done the 34 on that tumor the first time, because it was very, very SMA positive, somebody thought, what else can it be? It's a leiomyomatosis. So what are the lessons that we have learned? Okay, the lessons that we have learned is that the 4 iconic stains used, SMA, desmin, CD34, and S100 protein must be religiously applied and interpreted. There are no shortcuts. Okay, SMA is expressed in many spindle cell lesions, not only in smooth muscle tumors, including carcinomas, and desmin is very seldom negative in a smooth muscle tumor. So the moment that desmin was negative, somebody should have thought, what is this funny smooth muscle tumor in which there is no desmin? Now, in case it happens that desmin is negative, and once in a blue moon it does, then the suspicion of, and if you think that this is a smooth muscle tumor, then please do HCAL desmin. Okay, if HCAL desmin is strongly positive, then it confirms smooth muscle derivation. If it is negative, then it is not a smooth muscle tumor, exactly like how our tumor was. Okay, our tumor was a gastrointestinal stromal tumor. Okay, now let's get to case number 4A and 4B. All right, who's going to take that? Is Shashank there or has he gone? Are you there, Shashank? Or is he muted? Never mind. Kedar, come on. Are you there, Kedar?
I'm there, ma'am.
Good, come on, take this
This
case.
picture, this section under study shows a well-encapsulated lesion. The subcapsular tissue appears to be homogeneous at this final location.
Okay.
And surrounding the capsule, some connective tissue is seen.
Okay. What kind of connective tissue? What kind of connective
It
tissue?
appears to be fat and collagen, ma'am.
Fat and collagen. That is this. But what is around this thing? Kedar? You said that this is well encapsulated.
It could be a nerve sheath, ma'am.
What are you saying about this tumor? Do you think that this is in continuity with that? Obviously, the tissue is in continuity, right? So what
Yes,
do you mean by well encapsulated? I see that
All of
here.
it.
Huh?
Yes,
So how do
well
you describe this? Well encapsulated? Okay, maybe. Now what are you seeing here? You've seen all these sections.
Yes,
So
ma'am.
what do you see?
Ma'am, I can see spindle cells.
Spindle cells. You can't see any spindle cells at this magnification. Okay,
No.
you are seeing. You see very dense pink areas, eosinophilic areas at the periphery, which suggest that there must be collagen over there. And as you
Yes.
come towards the center, you see less and less pink until it becomes actually blue. Do you see this or not?
Yes, ma'am, I can appreciate it.
So
Yes, ma'am.
that's what has to be appreciated. The pink has become less pink and then it has become blue, which tells you that this lesion has got degrees of collagenization and myxoid change that you can see. And it's very unevenly cellular as well. Look at the cellularity on the right hand side. Very,
Yes,
very almost acellular in some of this. Now we can go to the periphery. You see the collagen of the periphery, all right? and then you come towards the center. It becomes, yes, there is collagen, but it's becoming also more mixoid. There you are. Okay. So now come on, describe this. Now you can make out that this is spindly, right?
Yes, ma'am.
Okay, very good.
I can make out a large population of spindle cells by mixoid appearing stroma.
Yes.
And admixed with collagen.
Admixed with collagen. Is that all you want to say about collagen? Sorry about this echo. What do you want to say about the collagen? Anybody wants to help him with the collagen? All right, Kedar, describe the cells at least.
Cells are spindle cells, ma'am. They are elongated in shape, having an elongated nucleus, and the pattern appears to be haphazard.
Pattern happens to be haphazard. I don't think so. No, there are fascicles. They may
Yes,
be
there are
interrupted
two
fascicles and rather poor fascicles. You can see that. Yeah, but okay. But what do you notice about these spindle cells, Kedar? And that's why it's important to
Parents.
make observations. Elsa, you want to help?
Ma'am, buckling of cells.
Ah, so the nuclei are buckled and the cells are also buckled. Now you can see that the cells are long. There are cells. Look at this. Look at the length of these cells, and the cells themselves, the cytoplasm is wavy. You can see the nuclei are buckled. Look at that beautiful buckled nucleus over there. Yeah, there are some of them that the nucleus is not spindly. You know, it's sort of triangular, but by and large, all these nuclei are spindly. And what do you want to say about the collagen, Elsa?
Shredded carrot collagen.
Ah, shredded carrot. Everybody knows shredded carrot. Yeah, what is shredded carrot? Can you explain that to Kedar?
Ma'am, collagen. Baby collagen.
Sorry. What? Elsa, please explain to him what is shredded carrot.
Ma'am, collagen bundles.
Collagen bundles. Yeah, there are collagen bundles. But why are we calling it shredded carrot?
Ma'am, baby.
Because it's wavy.
Yeah.
Huh? We call it shredded carrot because it's wavy. No, yeah, it's a nice fascicle. But why are we calling it shredded carrot?
No.
Did you understand? You just read in the books and said shredded carrot. What is a carrot, Elsa?
Wispy collagen.
Wispy. What is a carrot, Elsa?
Ma'am,
Have you seen a
vegetable.
carrot ever?
Yes, ma'am. Yes, ma'am.
Yes, you have. What is it?
A vegetable.
It's a vegetable. Okay. So you know how it looks like a carrot?
Yes, ma'am.
Okay. Can you draw me a carrot? Ask for draw it on the screen. It doesn't matter. Come on, draw a carrot. And take a nice orange thing and draw a carrot because the carrots are orange, right? Okay, so that is your carrot. Okay. Most carrots, if I am right, are long and they have a pointed. No, they actually look like the tibia, no? The carrots.
Yes,
That's what a carrot looks like, no? All right. Now you want to shred this carrot. Do you know what is the meaning of shred? What's
Grating.
shredding?
Grating.
Grating. Wonderful. You do it at home also, Diksha. Now start
Yes,
grating the carrot. And what will the grated bits look like? Come on, draw the grated bits. Use your orange thing and draw the grated bits. Yes, come on. They're going to be thinner than that. No, when you grate it, they're long and they are thin. Now everybody can see that the collagen over here, yes, it's long and thin. You don't even need to draw the second line. That is what is all. That's how this grated carrot looks. So you're grating and grating and grating and grating and you're getting long strips. Yes, isn't that so? Yes. So this collagen is like you have been grating carrots. Okay. And that is the famous shredded carrot appearance. Now, where's our friend Kedar? Do you understand, Kedar, what
Yes,
is
ma'am.
carrot appearance? Yeah, and it is very typical. But I want you people please to look at these nuclei. This is a very classic case, but just look at these nuclei. Not only are they spindly, they are thin and long. You know, it is as if somebody has taken, you know, when we were, I think maybe you two were in school, you used to use a nib and dip it in ink. I don't know whether you do it anymore. And if you have a thin point to the nib and you do little marks with that nib, this is how there is nothing finer and thinner than the nucleus of the spindle cell nucleus of this tumor. And what is this tumor now? I don't think I need to labor the point. Look at the thinness of this nucleus. I mean, you just don't see nuclei that are as thin as this. And of course, look at the wavy cytoplasm. Look at the wavy collagen that you are seeing over here. And of course, the shredded carrot appearance. And here at the periphery, you are seeing this collagen, which is a lot, and you're seeing fascicles. Okay, so there is the fascicles, and look at the amount of collagen that there is over here. Very good. And if you look carefully, you feel that maybe there are some entrapped nerve bundles, but I cannot swear to that, and I don't have a an SR protein to show you whether that is there or not. So what is the diagnosis? Is this spindle or not?
Yes, ma'am, it is spindle.
Very good. What pattern?
Fascicles and it was mixed with
stoma. And you have a well demarcated, end-sheathed. There is a sheath around this, and it's a cord-like structure. Did you see that? Because it was all continuous. So it is not a question of encapsulation. It is ensheathed. Okay, so really, this is something that the woman had on her arm, but it is like almost flexiform, but it isn't quite so. All right. So what is the cellular content now?
chiefly composed of spindle cells, ma'am, and
Yes.
collagen.
But it is characteristic, and I want you all to notice this. It is the characteristic thin, wavy nuclei, wavy cytoplasms, and shredded carrot collagen. Okay, which is so typical. Now, what next? What do you want to do now? Kedar, what next? We've written the description. We've done everything.
Give
Now,
differentials, ma'am.
give differentials. Okay, what are your differentials?
And one, it could be neurofibroma,
I see. And
could be schwannoma as well.
schwannoma as well. Acha, okay. It's a neurogenic tumor. Could it be anything else? And the answer is, if you make an educated guess, it is a neurofibroma. It cannot be a schwannoma. Have you ever seen a schwannoma? And that's what I'm telling you. You guys do not make observations. This is the thin, wavy UTI. You have never seen it in a schwannoma. You will never see it in a schwannoma. If you've seen
Can
this,
we call it plexiform neurofibroma?
yes, it is quite right. It can be a plexiform neurofibroma because it is in that in those bundles, and they have a sheath around it. Okay, excellent. All right, so it's a neurofibroma. Good. Now, how would we prove this? Yeah, Kedar?
The 4 iconic IHCs, ma'am.
Oh,
Yes, and
really?
firstly.
I don't think we need to. We don't do IHCs just for the sake of doing IHCs. Okay, there is only one diagnosis.
Yes,
Okay?
Spindle.
And even if you thought it was a schwannoma, there is no way that you would be able with your 4 IHCs to prove whether it was to distinguish a schwannoma from a neurofibroma. There is only one diagnosis, and that diagnosis is a neurofibroma. If anybody does immunohistochemistry on this, they should be shot because they're wasting time, energy, money, and it only tells you that you are not confident of your histology. Okay, so have you understood this, Kedar? It can
Yes,
never be a schwannoma. Why?
Because of the characteristic spindle cells we see in this particular case.
Absolutely, and you've got the myxoid stroma and the wavy bundles and the shredded collagen. You don't need any other evidence that this is a neurofibroma. All right, and if anybody wants to know whether this is S100 protein positive, it is, and it is also expressing SOX10 in the nuclei. It is not to be done. This is only for demonstration. All right. If I have a student and the student does this, they would be shocked. Okay, here we are now. Who's going to do 4B? We have to go up again. Is Saida there? Saida, are you there?
Ma'am.
Saida?
Yes, ma'am.
Very good. Come on, Saida. You're doing 4B. Come on, read it. It's an enucleated module from the lateral aspect of the right knee.
Right knee.
Yes. So what do you see?
Ma'am, in the scanner view, we can see hypercellular and hypocellular areas.
Is that what you're really noticing in the scanner view? It's an encapsulated lesion. No, that's what one can see. Beautifully encapsulated. Without a doubt, it's completely encapsulated. Right. So this is an encapsulated lesion. Now you can see that even in hyper. Yes, come on, it's got a capsule. Now what do you see here? Come on, Saida, quickly.
Ma'am, the hypercellular Antony A areas are in them hypocellular Antony B areas.
Yeah, can you see any Antony B areas over here? Where are they? What are you seeing over here, Saida?
And the hypocellular areas.
Hypocellular areas. Which are the hypocellular areas? Now please show me the hypocellular areas. Saida, here. Yeah, show me the hypocellular areas.
The pink areas.
Sorry?
These
No, show it to me, no. Use the second pen. Oh, this. No, you're not using the second pen. Because that's why it's disappearing. Anyway, I know what you were showing me. I will do it. You are saying that these are hypocellular areas, right? All these? Yes? Is that what you're saying, Saida?
Yes, ma'am.
All these are hypocellular areas. Everybody agrees that these so-called hypocellular areas are Antony B?
No, ma'am.
No. So please tell one of you tell Saida what is wrong. Yes, Deepali. Why are these not Antony B areas?
These are the Verrucate bodies.
These are Verrucate bodies. Well, they are collagen, yeah. And when we talk about, you may call them Verrucate bodies, or they're not specifically like Verrucate bodies, but you may wish to call them Verrucate bodies. But what I'm telling you is that this Antony B areas are loose. This is collagen and it is dense. That's what you have to understand. Okay, so this is what you thought, Saida, was an Antony B area. It is not. Okay, now what are we coming across over here? Suddenly we are beginning to see that the palisade. Oh, we forgot to mention that there was palisading, right?
Yes, ma'am.
Palisading. Yeah, this is a very palisaded tumor. And now what are we seeing over here, Saida? This is an Antony B area. You see this? And you know what it reminds you of? We just saw it a little while ago. What does it remind you of? You saw something like this a little while ago. What is it? Saida? You saw it in that gastrointestinal stromal tumor. You saw the vacuolation of the cells, and you saw the coalescence of the vacuoles within the cells, and the cells then die out. And that is why you saw that there were pseudocysts over there. And it is so often, if you have a lot of Antony B areas in a schwannoma, it becomes cystic. And that's how schwannomas sometimes just present as cysts. And you're surprised that when you cut it, you'll find a thin rim of collagen and, of course, spindle cells around these tumors. But here is the Antony B area. Okay, what you were seeing before, and look at this palisade. Yes, these are Verrucate bodies, and here is the Antony B area. So Antony A and Antony B, and you also see blood vessels. Many of them have got a hyaline wall. This does not. But you get two types of blood vessels. One of them is like this, and these are so thin-walled that very often schwannomas become hemorrhagic. So there are different kinds of change that can occur in schwannoma. One is cystic change. The other one is extensive hyalinization. Yeah, you can imagine how this collagen will cause extensive hyalinization. And the third is hemorrhage. These are the three changes. Of course, people talk about degeneration. It's not. And when you get a lot of these kind of changes, and the Schwannian part of the tumor is very paucicellular, or it is seen in different areas, maybe only near the capsule or in the center. These can be quite difficult to diagnose, and they are often referred to as an ancient schwannoma. There's nothing ancient about it. It's just been there long enough to undergo hemorrhage and hyalinization or cystic change. Okay, so see this beautiful palisading? Really nice. So what is this diagnosis now? Come on, Saida. Is it a spindle cell?
Yes, ma'am.
Yes, very good. What is the pattern? It is circumscribed. It is encapsulated.
And
There are fascicles and palisades. Yes. There's collagenous stroma with looser foci, which we refer to as Antony B. And what is the cellular content?
Spindle cell.
Yes, very good. So what do we do next?
I see.
Oh no, we don't do IHC. Saida, we're going to do IHC. What is your diagnosis? What are the possibilities?
Schwannoma.
What is the possibility? It's an
Ma'am,
immunogenic tumor, right? And
malignant
like we said
peripheral.
before, what is the diagnosis?
Schwannoma.
Schwannoma, yes. So how will we prove that this is a schwannoma? Saida?
We're doing IC S100.
Oh, we don't do IHC and this. How? S100 tell you it's a schwannoma? Come on, Saida. How will S100 protein or SOX10 tell you that it is a schwannoma? Why will it tell you it's a schwannoma? Can it be a neurofibroma? If S100 and SOX10 are positive, can it be a neurofibroma? Yes or no?
Yes, ma'am.
So we just saw a neurofibroma that was S100 and SOX10 positive. So what's the problem? What's the reason for doing S100 and SOX10? So how are we going to prove this? Come on, do you have any other differential diagnosis, Saida?
Yes, ma'am. Malignant peripheral nerve sheath tumor.
Malignant peripheral nerve sheath tumor. Really? You thought that this was a malignant peripheral nerve sheath tumor, Saida? Really? Why did you say schwannoma? Do you think this was malignant? How would you make a diagnosis of malignant peripheral nerve sheath tumor? What do you require for a diagnosis of malignant peripheral nerve sheath tumor? Come on, Saida, what?
It will be highly cellular and with increased
Very good.
mitotic activity.
Exactly, and it should have necrosis. And there is nothing like that over here. There's no mitotic activity, there is no necrosis, and it is not highly cellular, and it is beautifully palisated. Okay? Yeah, so I don't think that this is a malignant peripheral nerve sheath tumor. Even if it was, how will S100 and SOX10 help you? It's not going to help you, no? Benign or malignant, they may still be S100. So we don't need to do this. There is only one diagnosis either. So I didn't agree with Kedar because all you students have DDs. You do not need a DD if there is no DD. What is DD, Saida?
Differential diagnosis.
Yes. So everyone wants a DD. You don't need a DD if there is only one diagnosis, and this is a schwannoma. Have you understood that, Saida?
Yes, ma'am.
Yes. Yes, ma'am. So please don't say immunohistochemistry when you don't need immunohistochemistry. But if you want to see what the S100 protein looks like, that is S100 protein. And it doesn't tell you whether it is benign, malignant, whether it is a schwannoma, neurofibroma, or whatever. Have you understood that, Saida? Yes.
Yes,
Okay, good. And now let's come to 5A and 5B, and somebody has to do them both. So who's going to do this now? Elsa? Come on, Elsa. We're coming round full circle.
Ma'am, 5A is the last tumor resected from the thorax of an young adult, which was attached to the parietal pleura, and 5 is a mass symptom of the disease pattern.
Excellent. All right. Come on now. Tell me the similarities and tell me the differences.
Ma'am, both are cellular tumors.
Very good.
5A is more basophilic.
Yeah, but that's a staining tissue. No?
5B is partially circumscribed.
Well, we don't know. It's just a fragment of tissue, right? But they're very cellular. Yes, both of the tumors are cellular. There may be some areas where they're less cellular than in others. All right. Now that's 5A and these are 5B. Now tell me, are these spindle cells?
Yes, ma'am.
Very good. Pattern?
5A, they are arising fascicles.
Yes. Okay.
Ma'am, herringbone pattern.
In a herringbone pattern? No, I don't think so. I just think that they're in fascicles. No, in a herringbone pattern, and if you think this is a herringbone pattern where you see a spine there, okay, that's not a spine. No, in a herringbone pattern, the two ribs meet. They actually have to meet. Let me see if I can. Right. If you think that this is a herringbone pattern, that here is the spine, and I'm seeing some things like this, no, you're not seeing it. These are just fascicles that are radiating away from an area where there is. This is not a. Okay, come on. What are you seeing now on the other side?
They're also arranged in fascicles.
Okay, but what kind of? These are just in haphazard fascicles on the left hand side. On 5B, what do you see? We've seen this pattern before. No, this is in sheaves. We saw that this is a sheaf. You can see the way that these are fascicles cut in different directions because they are placed in that crisscross fashion. Okay, now go on. What do you notice about these two cases?
5A, the cells are spindly with moderate eosinophilic cytoplasm.
All right.
And
5B.
there are
Yes, it's actually different.
there are more eosinophilic.
More eosinophilic, it's just a matter of staining, right? So both of them are spindly. But you notice anything else? What did we say when we have to see spindle cells apart from the pattern? Now we have honed down on the cells. We have to look at the cells. That's why we went into the story of cells, pattern, matrix. Okay. So now tell me, we saw matrix in the neurofibroma. We saw matrix in the schwannoma. We saw matrix in the nodular fasciitis. Yes. Now tell me about the matrix over here. People have been forgetting the matrix.
One is collagen matrix in this collagen is eosinophilic matrix.
In fact, there is hardly any matrix. They're so cellular tumors. That there is hardly matrix. Look at it. There's a collagenized matrix. You know what collagen is that looks like. Every cell must have some amount of matrix, which will have to be some connective tissue. So there will be a little bit of collagen here and there, but not like what we saw in the nodular fasciitis. It is not like what we saw in the. Actually, it is a lot like what we saw in that story form. Right? It's just cells, and more cells. There is hardly any matrix to be seen. That's very important. Both of these tumors have got hardly any matrix. Okay. So now we have got very cellular tumors. Okay, and hardly any matrix. So now come on. This is on the left side is 5A and on the right side is 5B. Is it spindle?
Yes, ma'am. Spindle cells.
Okay, both sides?
Yes, ma'am. Both are spindle cells.
Both of them are spindle. Okay. What is the pattern?
And A is a fascicular pattern, B is sheaths.
Sheaths. Yes, fascicles and sheaths. Excellent. And then there is next to no stroma. There is really no collagen. There is no collagen that hits you in the eye. That's why you didn't even think matrix, because it was such a cellular tumor. Okay. And the other thing that we should look for when we have very cellular tumors is necrosis. There's no necrosis in this tumor. Now that's very, very odd for cellular spindle cell tumor. You can literally see it. But there are some other things that are odd. Okay, what is the cell content?
Spindle.
Tell me. What is it? It's extremely cellular spindle cell proliferation. Yes, they're very cellular. And did you notice whether there were any mitoses?
Very few.
Extremely few. Now here is a very funny thing. All right, there's no necrosis, there's no mitosis, and yet no mitoses are very few. And yet the cellularity of these two tumors is so very, it's exceedingly cellular. Okay, so what next do we have to think of possibilities, right? So what are the possibilities? There's only one possibility, right? This cannot be benign. There are no mitoses, yes, but do you know any benign spindle cell tumor that is so cellular, which doesn't, yes, you get some cellular leiomyomas, but they have extremely pink cytoplasm. The cytoplasm is not pink. So there's only one thing, and this is a spindle cell sarcoma. But what are these funny spindle cell sarcomas that do not have, mitoses that are consonant with their cellularity, and they don't have necrosis? And if you know about this, then you know what these tumors are likely to be. So what is the educated guess on H&E? On both sides? This side it's a sarcoma because it's in the arm. Over there, what is it? Well, perhaps it's a synovial sarcoma, maybe MPNST, God knows. That's the educated guess. So what next should we do?
Immunohistochemistry.
Immunohistochemistry. So what immunohistochemistry?
SMA, Desmin, S100.
Yes, so every time you have a soft tissue sarcoma, that's what you have to repeat. So SMA, Desmin, CD34, S100. Now we did it. And they were all negative. Okay, let's do 5A first. SOX10 was negative, but PAN-CK was focally positive and the EMA was focally positive. Okay, on the other hand, on 5B, SMA and Desmin negative. Look at S100 protein and CD34. They were both positive. Now that's an odd thing. Okay, and the SOX10, S100 protein is positive, but the SOX10 is negative. We did not have any cytokeratin and we did not have an EMA. Now, why did we do cytokeratin and EMA? Come on, you know this. Also, why did we do cytokeratin and EMA?
To rule out carcinoma.
To rule out carcinoma. Do you think that you know the history? What's the history? You think you're going to get a carcinoma?
No.
No. So not to rule out a carcinoma. We think that these are spindle cell sarcomas, but yet we did cytokeratin and EMA. Come on, Elsa. You know the answer. We have to answer the question of which sarcomas that are spindly and cellular might express cytokeratin and EMA. And this one's certainly, yes? There you are, synovial sarcoma. Yes, somebody saying epithelioid in the chat box. If it was epithelioid, they wouldn't be spindle. We are talking about spindle. Yes, so you are right, Elsa. If you see a very cellular spindle cell tumor, albeit that it is monophasic, yes, you must think if all this SMA, Desmin, 34, S100 protein, SOX10 are negative, the next thing that you have to do is cytokeratin and EMA. Okay, so we did it. Okay, and we did everything on the other one because, that could as well have been some kind of synovial sarcoma, although to our great surprise, we found that 34 and S100 protein were positive. Okay, PAN-CK and EMA were negative on this case. Okay, so now let's come to 5A. Should we think of a synovial sarcoma? The answer is yes. Why? Because PAN-CK and EMA were focally positive. It is a very, very cogent diagnosis. Yes. Over here, we have to do something else because now what is this funny thing? CD34 and S100 protein. Is it unlikely to? It is, of course, unlikely to be a synovial sarcoma. That one is likely to be a synovial sarcoma. It's unlikely to be an MPNST. Why? Why is it likely MPNST? It is a malignant peripheral nerve sheath tumor.
SOX10 is negative.
Okay, because SOX10 is negative. But it might be negative.
And there's no necrosis, ma'am.
There is no necrosis. Wonderful. Absolutely. There is no necrosis. Nobody should make a diagnosis of an MPNST without necrosis. I mean, you have to be with your back to the wall and you can't think of anything else if you want to call an MPNST an MPNST when there is no necrosis. Okay, so there is no necrosis, so it is extremely unlikely to be an NST. No, it's quite possible that it is some uncommon entity and we will have to find out what. Now on this side, I think it is a synovial sarcoma, so what should we do to prove it? What should we do?
Additional immunohistochemistry, ma'am.
Yes, somebody in the chat box says, could it be an angiosarcoma? All right, we will discuss that in the questions. So we have to do immunohistochemistry. Yes, and the common immunohistochemistry that we do for synovial sarcoma is TLE1, CD99, which is big 2, BCL2 calponin. But nowadays we have a little bit more specific immunohistochemistry. We do INI1, which is SMARC V4. That is what we do on INI1 because in synovial sarcoma you get patchy loss of INI1. We've noticed it now many times in these tumors, and of course you can get the SS18 protein because you get a translocation, right? SS18, SSX, and now we have an antibody to the SS18 protein. On this side, we'll have to check and see which uncommon entity we are going to find. Now let's look at 5A. Come on, read this now. I'm showing you the immunos.
SMA. The cells are negative.
Very good. What is positive?
The vessels.
Yeah, so it's an internal control. Yes, very good. Vessel walls are positive. What about this?
Desmin also negative, ma'am.
Very good. Desmin is negative. Excellent.
And CD34 also control as vessels are positive.
Excellent. Then
S100 negative, ma'am.
Yeah, so 34 is negative, S100 is negative. Now, what is this? Cytokeratin and cytokeratin. Now you can see how the spindle cells are very focal, and this happens with all monophasic synovial sarcomas. If you expect that every cell or every second cell is going to be positive, you will not find that it is so. Right? Look at the individual foci here and there that are positive. Similarly for EMA, and sometimes the EMA is better than the cytokeratin. Okay, so you see some of the spindle cells with a very weak and focal EMA. Now we can see what I was telling about. CD99, that's MIG2, right? And it is very densely positive in this case. In fact, in synovial sarcomas, we normally want to see CD99 or MIG2 as a membrane. In synovial sarcoma, you see it as membrane and cytoplasmic. You just don't see a good membrane in synovial sarcoma, and still you read it as positive. This is TLE1. What has it marked, Elsa?
Not positive. Diffuse
Yes, what has it marked? What has it marked? It's not just to say that it is positive. In which compartment of the cell is TLE1?
Ma'am, nuclear positive.
It is nucleus. Yeah, you see the spindling of the nuclei. It's a beautiful nuclear positivity. All right, here is BCl2. Is it positive or negative?
Positive, ma'am.
Right. What is it? Nuclear or cytoplasmic? No, it's not. BCl2 is never nuclear. Huh?
Cytoplasm.
And calconin?
Also cytoplasm.
Cytoplasmic. Yes. So the only thing that is crisp and has taken on the shape of the nucleus is
TLE1.
TLE1 because it is nuclear positivity. Now this is ionI1. Okay, and ionI1 is a
Also
nucleus.
cyanide.
Yes, you see it. It's present in some here and there. But what you're seeing here is internal control. No? The internal control is the vessels. You can see that the vessels shouldn't lose ionI1, so that's an internal control. But you see that there are lots of spindle cells that have lost ionI1. And this is SS18 protein. Is it nuclear or cytoplasmic?
Nuclear, ma'am.
Nuclear. Very good. So now we know that this is a monophasic synovial sarcoma. All right. Very good. Excellent. Now we come to 5B. I told you CD34 was positive. Look at the amount of CD34. S100 protein is positive. You see that? It's nuclear positivity. You never read an S100 protein as positive in a sarcoma unless it is nuclear. Okay? S100 protein may be positive in the cytoplasm of histiocytes, but you never read it as positive in anything else. Melanoma, sarcoma, any other thing. Apart from histiocytes, it has to be in the nucleus. SOX10. Positive or negative?
Negative, ma'am.
Negative, yes. So, and we have the other negative immunostates. There was no SMA, there was no desmin, there was no CK, there was no EMA, all right? But now we are beginning to realize that there are these funny tumors. They are spindle, they are often very low grade, they look like synovial sarcomas, they are fascicles, they show you co-expression of 34 and S100. And many of them, not all of them, express this marker on immunohistochemistry, okay? And that is NTRK. It's a marker that is expressed in the nucleus of these tumors, okay? And these are being called as S100 CD34 positive sarcomas. And some of you who are interested, nobody's going to ask you this in the exam. You will never be shown a case. But I thought since we had it and we could see that tumors look the same and immunohistochemistry separates these two, okay? And they show recurrent fusions involving RAF or BRAF or NTRK genes. And you can look up this particular article, okay? And that's the abstract. And it can be confused also with peripheral nerve sheath sarcomas if you happen to get a biopsy and there's no necrosis in these tumors. Okay. Now I know that we are almost at the end, and I'm not going to ask. I'm just showing you this case. Okay, and I'll tell you the answers to the next two cases. Here was this 14-year-old child. I haven't said this to you, with fever, breathlessness, and chest pain. And obviously there was a huge mass in the left hemithorax, and that's why this child was tachypnic and had tachycardia. And they debulked this mass. I don't know, they did a biopsy, but they didn't get an answer, so they debulked the mass. And look at it, how big it was, 20 centimeters. And this is it. Okay, now that you did this, the last case, maybe you can do last two cases. Elsa, tell me, what is different between what the last two cases were and this? This is also extremely cellular.
Ma'am, these are not arising fascicles.
Okay, you can't see that. What is it that is different under low power? And that should have hit you straight away.
Mixer.
No. Come on, Priyamada, are you there?
Necrosis.
Ah, yeah, she said it. It's necrosis. This is a necrotic tumor. And it is, it's very cellular, but it is necrotic. And then when you see an extremely cellular tumor, look at this. Okay, it is spindle cell. It's also to some extent epithelioid. And look at the necrosis. This cannot be what? It cannot be a synovial sarcoma, no matter what anybody says. Okay? Yes, it has spindle cells. Look at the amount of necrosis that is present. And you're right, these spindle cells are not in fascicles. So then, because it is a child, because it is in the chest, just like our synovial sarcoma was in the chest, okay? It could be a pleuropulmonary blastoma, MPNST, naturally, because it's got necrosis, undifferentiated sarcoma of some sort, or rhabdomyosarcoma. And you have to do the immunohistochemistry. And what did we find? That the SMA was positive, and there was very focal pancytokeratin. Everything else was negative. So now, come on, Priyamada, can it be a synovial sarcoma? It has got some focal pan-CK. Can it be? And we just saw a synovial sarcoma in the chest wall.
Yes, ma'am.
So can it be a synovial sarcoma? Yes, ma'am. Just like Priyamada. Okay. Aditi, is Aditi there or she's left? Diksha, can this be a synovial sarcoma?
No, ma'am.
Why?
Lot of necrosis.
Because there is huge amounts of necrosis. And look at the mitotic activity. Now, synovial sarcomas, however cellular they are, just do not show mitotic activity. And we said that. So this is something that you have to realize about synovial sarcomas. So it can't be a synovial sarcoma. And yet, look at the synovial sarcoma markers. There's TLE, there's CD56, there's BCL2, there is MYC2. So is it a synovial sarcoma now, Diksha? What? So is Priyamada right? There was some CK and there was some SMA, and we have all the synovial sarcoma markers. Yeah, tell me, Diksha.
Ma'am, slide has not moved it.
It hasn't moved for you? Has it moved for everybody else?
Yes, it has moved.
Yeah, it has. Okay.
Yes,
So now, Diksha, has it moved for you?
Yes, ma'am.
Okay. So then now is it a synovial sarcoma?
Yes, ma'am. TLE1 is diffuse.
The answer to this is no. It is not a synovial sarcoma. And what is the lesson that you learn? That you do not make a diagnosis on immunohistochemistry alone. All right? You do not. There are some good reasons for not calling this a synovial sarcoma. It has no necrosis. It has no mitosis. Yes. And this tumor, so we have to know why. And I told you that. All right? But we did something else as well. And this is just you don't need to even remember this. We did a marker that is quite often lost in malignant peripheral nerve sheath tumors. And this is a histone marker. It's H3K27ME3. And you look at the nuclei. Nuclei have a dot, but the nuclei are negative. Okay, if this was a tumor that has not lost expression, because all normal tissues show expression of this marker. And malignant peripheral nerve sheath tumors looks this way. Okay, this thing would have been densely brown, but it is not. All that is left is one spot in each nucleus. Okay, the diagnosis was a malignant peripheral nerve sheath tumor, and it tells us something that the malignant peripheral nerve sheath tumor can express TLE, can express CD56, it can express all of the BCL2, it can express the synovial sarcoma markers. It will not express SS18. That it will not express. Okay, but everybody doesn't have SS18, so it's something that you have to be aware of, that you don't make a diagnosis just on immunohistochemistry. All right, sorry. So this is about H3K. You don't need to know about this. Okay, but something interesting. H3K27ME3 is expressed on the X chromosome. Okay, so a dot in every female nucleus represents the inactivated X chromosome. It's like a bar body, and if you're interested, go and look up what is a bar body. Okay, so what is the diagnostic significance? I told you that is expressed in up to 72% of malignant peripheral nerve sheath tumors. There's complete loss in about 37% of melanomas. It is rarely lost in some other subset, which we don't need to know. But now that you know all this about H3, please tell me what is the sex of this child. Yeah, come on, Priyamada, what is the sex of this child? I told you it was a child. I didn't tell you whether it was a male or a female. So come on.
Female.
Why is it a female, Priyamada?
Because this H3K27
inactivated X chromosome. Okay, so that inactivated X chromosome is seen as a dot in this nucleus. Very good. It was quite interesting. The answer was a female. Okay, this is just to tell you, don't bother about the MPNST, but this is about the synovial. You never get pleomorphism. You never get necrosis, and I'm saying never. Okay, never do you get. Is this tumor myxoid? So if you get a myxoid tumor, a tumor with necrosis, a tumor that is pleomorphic, and it is full of mitoses, excuse me, that's not a synovial sarcoma, and never should be called a synovial sarcoma. So these are 4 things that you should not see in a synovial sarcoma: myxoid change, necrosis, pleomorphism, and high mitotic rate. You do get TLE1, but you can't rely on that, as I told you, because TLE1 is regularly expressed in MPNSTs, and I would not make a diagnosis of an MPNST without necrosis. Of course, MPNST can be pleomorphic and lots of other things. Yeah. Okay. So there are some lessons that we learned. Okay, and the lesson about MPNST is expression of S100 protein does not equate with either neurogenic or melanocytic origin in a spindle cell tumor. We saw a case just now which had S100 protein and CD34, and it was not either a neurogenic or a melanocytic tumor. Absence of SOX10 in a tumor expressing S100 protein must be viewed with caution. So also the absence of necrosis. How do you make a diagnosis of MPNST? To do it, if you know that there is origin from the nerve, the presence of a pre-existing neurofibroma, in a patient with von Recklinghausen's disease, that is multiple neurofibromatosis, even in the absence of SOX10 X100 protein, it doesn't matter. If you have neurofibromatosis and you get a sarcoma, that is an MPNST. Just so these are the different ways in which you can come to the conclusion that you have an MPNST and you do not need any further immunohistochemistry or anything. All right. Now I'll quickly tell you what are the answers to these other things. This is a retroperitoneal mass in an adult male, huge mass, and you see this. It looks as if it's encapsulated, but it's so huge that it has pushed all the tissues to the side and it looks like it has a capsule. Okay, and it's myxoid. It's not only myxoid, it's pleomorphic. You can see that. It's myxoid, partly collagenous here and there, and pleomorphic. So what is it? Of course, it's spindle. It's got fascicles, it's collagenous and myxoid. There is no necrosis. And the cellular content, yes, it's spindle cells, moderate pleomorphism, and there are mitoses in this. Okay, there are no necrosis, but there are mitoses. So what do we do next? We think of possibilities. We know that it is a malignant spindle cell tumor, but it is also pleomorphic. So what is the history? History is that it is a large retroperitoneal mass. Now, I don't know whether you do this, but I never take a retroperitoneal mass as history. I want to know whether it is in the upper retroperitoneum or in the lower retroperitoneum. Why? Because if it is in the lower retroperitoneum, then I would consider a sarcoma. If it were in the upper retroperitoneum, there are other organs there, like the pancreas and the adrenal and other organs, which can give rise to a sarcomatoid carcinoma. So it can be a spindle cell sarcoma, carcinoma arising from those organs. So never take a history for granted. You must find out where in the retroperitoneum. Okay, so we have to do immunohistochemistry. Okay, so we do this SMA, Desmond, 34, S100, SOX10, pan-CK, EMA, and they were all negative. Okay, so they're negative. Now what do we do? Is there anything that we can do? Should we rule out a synovial sarcoma? There's no necrosis. There are very few. There are mitoses. And the answer is no. This is pleomorphic. It can never be a synovial sarcoma. No, synovial sarcomas are never pleomorphic, necrotic, or mitotically active. So that's not a synovial sarcoma. So what do we do? In the retroperitoneum, there's one thing that we should always consider. You can do any number of immunohistochemistries and they may turn out to be negative. You must think of a D-differentiated liposarcoma. All right. So what should we be looking for? What immunohistochemistry is this? Anybody tell me? Who's a third year person now? Yes, let's ask. Who's this Chandana? Chandana, you're a third year? See, this is the H&E and this is an immunohistochemistry. And lots of people in the chat box are giving you the answer. What immunohistochemistry is this? If I want to prove that this is a D-differentiated liposarcoma. Have you heard about it, Chandana? Anybody else have heard about it?
MDM2?
MDM2, yes, this is MDM2. Wonderful. So the diagnosis is a D-differentiated liposarcoma. All right. Now you can find out about MDM2 if you want. And this is the last case. Again, it's a retroperitoneal mass in the adult. And in an adult, and you can see, look at it, it's whirling. It is spindle. But if you notice the character of these spindle cells, what is the character of these spindle cells? They have a plump nucleus. Okay? And there is a looseness to this. So they are whirling around like that. Yes, some of them are in fascicles, but it is plump. Look at this. Look at this whirls. Yeah. And the whirls should be reminding you of something. That's a spindle cell thing on the left-hand side. Look at the whirls. But they're plump. Now, would you consider this cellular, like, in a synovial sarcoma or in that other tumor, which was NTRK positive? Yes, Kedar? Do you feel
Not as cellular as synovial sarcoma.
it's not? In fact, there are large gaps here and there, right? Where the cells are not there. There's a certain amount of pleomorphism. You see these nuclei? Yeah. So if anybody wants to tell me that this is a synovial sarcoma, I will say no. There is synovial sarcoma monophasic has no pleomorphism at all. Please take that as a given. And here you're seeing some pleomorphism. All right. So is this spindle? Answer is yes. It's got fascicles and whorls, and again, no real stroma. So somebody might think, oh yes, maybe it is a synovial sarcoma. No necrosis. Cellular content, plump spindle cells, moderate pleomorphism, no mitosis. So what next? We have to think of possibilities. And so we say spindle cell tumor. Because we don't know. We take a history, it's retroperitoneal, and in this case, it was in the lower retroperitoneum. Okay, you have to ask that. Where? So educated guess, I'm sorry, but there is no guess that is possible at all. All you can say is that it is a spindle cell tumor. You don't even know. There are no mitoses. There's nothing. Is this some low-grade sarcoma? Is it a benign tumor? Well, we can't say anything. So what next? We do immunohistochemistry. All of this is negative except for EMA. So once again, is that a synovial sarcoma? What do you think, Kedar? What do you think? Only EMA is positive. And it's no necrosis, very few mitoses. Is it a synovial sarcoma? Come on.
No, ma'am.
Why?
Just based off this information.
Not based on this information. But do you want to do the synovial sarcoma markers?
No, ma'am.
Why?
Because there is no.
Because?
Because it is
Oh, it's not
and
that.
there is
It's
some
because there is
pleomorphism.
Kedar. If there is any pleomorphism at all, you do not want to think of a synovial sarcoma, right? So should we rule out a synovial sarcoma? No. It could be, but it's very unlikely because of the pleomorphism. So now what should we do next? We've done everything that we are supposed to do. Everything. SOX10, PAN, CT, EMA, whatnot. So what should we do? When you come and you're stuck, you go back to the drawing board. Or somebody says, do ALK. Well, not a bad suggestion, but just do ALK out of the blue. Okay, there has to be a reason to do ALK. So then we go back to the drawing board and look carefully at the histology. Now come on. What is it that we have missed? And what is the diagnostic clue?
Lymphocytes.
Lymphocytes. Very good. Excellent, Elsa. So now what does this mean?
Inflammatory.
Oh, so you think that we should do ALK, huh? Now will you look very carefully, Elsa, and tell me, besides lymphocytes, do you see anything else? Any other inflammatory cells?
No, ma'am. There is no plasma cells.
There are no plasma cells, there are no eosinophils, there are no neutrophils, there are only lymphocytes. So now, the person who wrote ALK, do you still want to do ALK? The answer is no. When I see lymphocytes and I see whorls and I see, yes, now that person has got the diagnosis. I see minimum pleomorphism and I see only lymphocytes. And that's why I hate this term lymphoplasmacytic. There is no such thing as lymphoplasmacytoid or whatever you people call it, infiltrate. These are only lymphocytes. You have a world appearance and lymphocytes, and there is only one diagnosis. And somebody has said it in the chat box. Do any of you know what that diagnosis is? Yes? What is it? It is an FDC, that is a follicular dendritic cell sarcoma. And you do a follicular dendritic cell marker. It's either 21, 23, 35, D240, Bassin, whatever. Okay? This is a FDC sarcoma. So what I'm trying to show you is that you have lots and lots of different things that can be spindle cells. But what I showed you in the beginning, I don't care whether you make these diagnoses or not. You cannot miss a neurofibroma, you cannot miss a schwannoma. If you miss that, there's something terribly wrong. Okay, those two you just cannot miss. You cannot, sort of miss a nodular fasciitis, or at least miss myofibroblasts. All right. The ulcer, I just put it there so that you could notice what happens in a lesion that is repairing, or acute inflammation that is undergoing reparation. Okay. So what have we learned about undifferentiated spindle and pleomorphic tumors? All right. When common markers don't show you lineage differentiation, look for expression of MDM2 or expression of FTC markers, especially if there are lymphocytes. Also look for loss of expression of H3K27ME3. And never forget to ask for a history of irradiation in the past, in which case you may get no lineage markers, because it's an undifferentiated sarcoma that occurs in an irradiated field, or a history of neurofibromatosis in the family. Okay. Now, I just want to show you, we saw so many of these tumors. Okay. I just wanted to tell you that immunohistochemistry was not required in these cases, in the ulcer, in the nodular fasciitis, in the neurofibroma, in the schwannoma. Okay. Synovial sarcoma, yes, you need that immunohistochemistry. And the reason I say this is that synovial sarcoma today can be treated in a relatively specific way. So if you can call something a monophasic synovial sarcoma, if it's biphasic, the diagnosis is easy. Monophasic, you must do it. And of course, this we would not be able to diagnose unless we had these two. Yes. Dedifferentiated liposarcoma, often you've got a large retroperitoneal tumor. Look carefully for lipoblasts. And if you see them, if you want to do an MDM2 to confirm it, fine. But there's not much that one can do about a dedifferentiated liposarcoma. So if you call it, just a high-grade sarcoma, you haven't done anything terrible. FTC sarcoma, yes, you can make you get a good suspicion that this is an FTC sarcoma, and you use the immunohistochemistry. But what I want to tell you is, this is a place where this and the gastrointestinal stromal tumor, you do need immunohistochemistry. And you can be faulted not for doing immunohistochemistry to make a diagnosis of dermatofibrosarcoma protuberans if it is a small lesion, and you could mistake it for a dermatofibroma. This you need immunohistochemistry for, and for a gastrointestinal stromal tumor, you cannot do without immunohistochemistry. You do need to confirm that. Okay, so that's the end of my talk. If there are any questions, I'll answer them, but I think most of you are very tired. And I want to thank all of you. I called you Hanisha, but your name is actually Saida, Dipali, Elsa Joy, Aditi, Diksha, Pritika. I don't know where Shashank went, he disappeared. But all of you, Chandana, Indumati, Priyamvada, Kedar, all of you, thank you. I don't think Indumati was here.
Thank you, ma'am.
Yeah, so thank you very much. If there are questions, I think somebody had a question about an angiosarcoma. That's the only one I'll answer. Okay. Are there any pressing questions?
No, not
Okay.
really.
No. So it was only angiosarcoma once. And I will tell you that the spindle cell angiosarcoma, all right, the spindle cell angiosacomas are extraordinarily high grade tumors. You don't get a low grade spindle cell angiosarcoma, and therefore you will get necrosis, you will get mitoses, you will get pleomorphism. You do not get a spindle cell angiosarcoma like that. But there is one form of spindle cell, since somebody brought up the angiosarcoma, there is an entity called an intimal sarcoma. An intimal sarcoma gives you the angiosarcoma markers, but it's a huge tumor that arises from a big blood vessel, whether aorta, or pulmonary artery, pulmonary veins, any of the big branches of the aorta or the inferior vena cava. But that may not have necrosis, it may not have any other thing that you would normally associate with a high-grade tumor, but it is so closely adherent to the vessel that I think you would have no difficulty knowing that it was arising from the vessel. And here is where MDM2 comes positive. So MDM2 is used for a dedifferentiated liposarcoma, for an intimal sarcoma, for an intraosseous well-differentiated osteosarcoma, and a parosteal osteosarcoma. Okay. So
Thank you, ma'am. Thank you very much, ma'am, for the bouquet of cases. And it was really very nice to